On September 18th, 2025, two seemingly impossible events occurred within 72 hours. The Kamchatka Peninsula of Russia was shaken by a 7.8 magnitude earthquake, the latest in a string of disasters that began in July, but 3 days earlier. Our planet also endured a G3 class geomagnetic storm as the sun awakened after 11 years of slumber. A coincidence, perhaps, but there was a third player in this cosmic drama. Comet Bialas, the interstellar visitor, was now hurtling toward our star, carrying a colossal plasma tail, half the size of the sun and growing larger by the day. For better or for worse, we were witnessing something that had never been observed in recorded history. So join me tonight as we explore to uncover whether these extraordinary events are mere coincidence, or if there is something far more deeply connected than science dares to admit. Part 1. The Sun is Awakening. On September 18th, 2025, the Earth shuddered. A powerful 7.8 magnitude earthquake tore through the sea off Russia's Kamchatka Peninsula, sending tremors across the Pacific Ring of Fire. But this is what makes the moment extraordinary. Just 3 days earlier, our planet had been struck by something entirely different. A G3 geomagnetic storm, one of the most powerful space weather events of the year, which swept through the magnetosphere like an invisible tsunami. 2 events, 1 weekend, and in between them, a question that would give any rational scientist pause. What are the odds? Our sun is awakening, after years of relative quiet, as solar cycle 25 reaches its peak, and the numbers tell a story that is both fascinating and unsettling. The Space Weather Prediction Center at the National Oceanic and Atmospheric Administration, or NOAA, had been tracking increased activity, numerous coronal holes, high-speed solar wind streams, and geomagnetic disturbances capable of lighting up the aurora as far south as Colorado. But this is where it gets interesting. The G3 class storm from the 15th of September did not originate from a solar flare or a coronal mass ejection. It came from something more subtle, more persistent, a high-speed stream from a coronal hole. Imagine the sun's magnetic field lines unfurling like a flower, creating a highway for charged particles to rush towards Earth at speeds of over 600 kilometers per second. The earthquake that followed was no ordinary aftershock. The 7.8 magnitude tremor occurred in the same region that had been devastated just 7 weeks prior by a massive 8.0 earthquake, one of the most powerful ever instrumentally recorded. The July 29th event sent a tsunami across the Pacific, triggering alerts from detection systems from Hawaii to Chile, tracking waves that could reshape coastlines. Any seismologist worth their salt will tell you that earthquakes are caused by tectonic forces, the slow, grinding dance of tectonic plates that has choreographed the planet's surface for billions of years. And they are absolutely right. But what if there's something more? Enter the third player in this cosmic drama, Comet Atlas, officially designated C2021-U1. This is no ordinary comet, it is a visitor, the third confirmed interstellar visitor to our solar system, a traveler from the void between stars heading for a close encounter with us on October 30th, 2025. It will reach perihelion, its closest approach to our star, at about 1.4 astronomical units. Before you start stockpiling canned goods, let me be clear. Comet Atlas pose absolutely no threat to Earth. Its closest approach to our planet will be about 1.8 astronomical units. That's 168 million kilometers, further away than the distance between the Earth and the Sun. This is not an extinction event. It's a scientific opportunity. But what makes Comet Atlas so remarkable? The Hubble Space Telescope observed it and found something extraordinary. This interstellar wanderer was already active, developing a coma, that fuzzy cloud of gas and dust, at a distance where most comets are still dormant. We're talking about a structure that may stretch 700 kilometers, about half the diameter of the Sun itself. Ponder this: an object from another star, carrying the chemistry, and ice forged in an alien stellar nursery, is creating a bubble of activity so immense it could swallow multiple Earths without them touching the sides. And it is doing this while still millions of kilometers away from the warm embrace of the Sun. I want to make one thing clear before we go any further. Mainstream seismology has not found a clear causal link between solar storms and earthquakes. The United States Geological Survey, USGS, the world's leading earthquake monitoring organization, maintains that tectonic forces are the cause of seismic activity, not space weather. We will explore alternative theories as we continue, but let's take this as established fact. However, the timing is rather strange. The geomagnetic storm of September 14th was caused by a recurrent transequatorial coronal hole, a persistent opening in the Sun's magnetic field that has been pumping high-speed solar wind toward Earth for days. This coronal hole, designated CH1316 by solar physicists, has facilitated many geomagnetic disturbances throughout September. High-speed solar wind streams from a coronal hole are different from the violent eruptions that we typically associate with space weather. Instead of a sudden shock, they create a sustained pressure that can persist for days. The solar wind density drops sharply, sometimes to less than 1 particle per cubic centimeter, while the velocity increases to nearly double its normal level, to 400 kilometers per second. For those of you who are following along, you can observe these conditions in real time. NOAA's Space Weather Prediction Center provides constant updates on the KP index, a measure of geomagnetic disturbance on a scale of 0 to 9. Anything above a level 4 begins to affect technology. A level 6 or 7 can disrupt power grids and GPS systems. The USGS maintains a database of seismic activity that is just as transparent. Every earthquake above a magnitude 2.5 is cataloged, analyzed, and published within minutes of detection, when the headlines get loud, and believe me, they will. These are your reliable sources of information. But let's return to our cosmic visitor. BA, Atlas, does not travel alone through this increasingly active heliosphere. October 2025 promises to be one of the busiest months for comet watchers in recent memory. Comet C 2025. Jai Swan will make its closest approach to Earth around October 19th to 21st. Passed within just 0.26 astronomical units, close enough to form a tail, visible with binoculars. Meanwhile, Comet C, 2022, with a magnitude of 6, is rapidly brightening with the forecast that it could reach magnitude 4 by the end of October, bright enough to be seen with the naked eye under a dark sky, assuming you know where to look for the many moving objects. A vibrant sun and an Earth reacting with some of the strongest seismic activity in more than 10 decades, coinciding as we will learn in the following sections. Some researchers have proposed possible mechanisms that could link these phenomena in a way that challenges our understanding of how the solar system operates as an interconnected system. Here is what we know for sure. The Sun's magnetic field extends far beyond its visible disk, creating the heliosphere which envelops all the planets and reaches out into interstellar space. When objects like Biatlat enter this range, they become part of an electrical circuit that spans billions of kilometers. Giant gas clouds can interact with the solar wind, the interplanetary magnetic field, and the complex system of currents that run throughout our cosmic neighborhood. The question is not whether these interactions occur. They certainly do. The question is whether they are strong enough to affect geological processes on a planet 150 million kilometers away. Whether the delicate balance of stress along a fault line can be shifted by changes in the electromagnetic environment that surrounds us all. As we delve deeper into this investigation, we will examine three distinct types of evidence. First, verified data, space weather, seismic records, and astronomical observations that no one disputes. Second, the controversial claims, hypotheses about the link between solar activity and earthquakes that are still being debated vigorously within the scientific community. Third, the purely speculative scenarios, the what-if questions that push the boundaries of conventional thinking. The journey begins with a deeper look at the Kamchatka Peninsula, where tectonic forces have created one of the most seismically active regions on Earth. But as we will discover, even the simplest geological explanation raises questions about timing, concentration, and the mysterious rhythm that seems to govern when the planet decides to release its stored energy. What would happen if an interstellar object carried with it a plasma cloud half the size of the Sun, encountering a star system with a fluctuating magnetic field? We are about to find out. Part 2. The Kamchatka Earthquake Swarm, an unprecedented seismic release. Let me paint a picture for you of what happened. On the 29th of July, 2025, at 14 hours, 55 minutes, and 10 seconds Coordinated Universal Time, the seafloor off the coast of Russia's Kamchatka Peninsula suddenly shifted. In just under 3 minutes, a fault zone that had been locked for decades unleashed energy equivalent to 32 billion tons of TNT, an earthquake measuring 8.8 on the Richter scale, which was so powerful it actually changed the length of Earth's day by a few microseconds within minutes. Tsunami warning systems across the Pacific were activated. The Deep Ocean Assessment and Reporting of Tsunamis, or DART network, detected waves propagating across the Pacific at nearly 800 kilometers per hour. Data from NASA's Jason series satellites confirmed wave heights exceeding 3 meters in the deep ocean, carrying enough energy to level coastal cities thousands of kilometers away. But what made this event extraordinary in the history of seismology was that it was not a surprise, at least not entirely. The Kamchatka Peninsula sits on one of the world's most active subduction zones, where the Pacific Plate dives beneath the Okhotsk Plate at a rate of about 8 centimeters per year. This constant collision had been building up pressure for centuries, creating the perfect conditions for what seismologists call a subduction zone megathrust earthquake. The subduction zone here is ideally structured to generate enormous seismic events, with the subducting Pacific Plate creating a sloped fault plane that can rupture over hundreds of kilometers at once. When it finally gives way, the overlying tectonic plate springs back like a compressed coil, displacing a massive volume of seawater in the process. The unusual aftershock sequence. What was unexpected was the unprecedented concentration of large events that followed. By mid-September, the region had experienced more than 40 aftershocks above magnitude 6, including several that could be considered major earthquakes in their own right. The magnitude 7.8 event on September 18th was just the latest, in a sequence that had seismologists around the world glued to their monitoring screens to understand why this concentration was so significant. We need to understand how stress transfers operate along the fault system. When a major earthquake occurs, it doesn't just release energy, but it also redistributes that energy. Areas that were previously stable suddenly come under increased pressure, while other regions experience what seismologists call a stress shadow, where the probability of an earthquake temporarily decreases. The challenge with large earthquakes, the challenge with major rupture earthquakes like the July 29th event, is that they can trigger widespread cascading failures. The initial rupture zone stretched nearly 600 kilometers along the plate boundary, but the stress change it generated propagated much further. Coulomb stress modeling by the United States Geological Survey showed The 10 nearby fault segments had their probability of failure increased after the main shock. The divergence between traditional and alternative views. This is where traditional seismology and alternative hypotheses begin to differ. The mainstream explanation for the September 18th event is straightforward. It was a major aftershock triggered by the stress changes from the July earthquake. Its magnitude 7.8 classification strongly confirms this interpretation. It is precisely the type of subsequent event you would expect in a sequence of this magnitude. But timing is a critical factor in science, and the timing here is surprising. The September 18th earthquake occurred just 3 days after a geomagnetic storm of G3 intensity swept through Earth's magnetosphere. Could this be a mere coincidence? Or is there a deeper connection between our planet's electromagnetic environment and the mechanical stresses that cause earthquakes? The September geomagnetic storm. Before exploring that possibility, let's examine what actually happened during those crucial September days. The geomagnetic storm began on September 14th, when a high-speed stream from a coronal hole impacted Earth's magnetosphere. Unlike the sudden impact of a coronal mass ejection, this was a prolonged pressure that built up over more than 48 hours. Ground-based magnetometers recorded magnetic field fluctuations reaching a level 3 intensity, strong enough to trigger widespread auroral displays and cause minor disruptions to more sensitive radio waves. The storm generated induced currents in the Earth's crust. This electrical flow follows geological structures and can reach surprising intensities along fault zones. The special conditions of the solar wind, the Center for Space Weather Prediction at the National Oceanic and Atmospheric Administration, recorded this event in detail, with solar wind speeds peaking at nearly 700 kilometers per second, while particle density dropped to less than 1 proton per cubic centimeter. These conditions created what some researchers call a solar wind vacuum, a low-pressure environment that, according to alternative theories, could influence tectonic processes through electronic coupling. The scientific view on this connection. Now, this is where we need to be extremely cautious. The view that space weather can trigger earthquakes remains highly controversial in the seismological community. A comprehensive review published in the journal Geophysical Research found no statistically significant correlation between geomagnetic storms and earthquake occurrences when appropriate statistical controls were applied. However, a few studies have reported weak correlations under specific conditions. Some researchers point to changes in atmospheric pressure, ionospheric disturbances, or induced currents as potential triggering mechanisms for earthquakes that were already critically stressed. The key phrase here is critically stressed. No one suggests that space weather can create earthquakes in a stable crustal region, the instability of Kamchatka. The Kamchatka Peninsula was anything but stable in September of 2025. The region had been experiencing increased seismic activity following a major earthquake in July. Aftershock sequences typically follow well-established statistical models, with the frequency of events decaying according to a power law, verified across thousands of earthquake sequences. What makes the September 18th event notable is not that it occurred. A large aftershock was expected after a magnitude 8.8 earthquake, but rather its precise timing relative to the geomagnetic storm. Statistical analysis is needed to determine whether this timing falls within the realm of expected coincidence, or if it represents something more significant. Proposed physical mechanisms. The physics of potential space weather-induced earthquakes involves several proposed mechanisms. Geomagnetic storms can create electrical currents in conductive geological structures, potentially altering pore fluid pressure along fault planes and changes in atmospheric pressure related to the heating of the ionosphere, which could theoretically affect the stress field of the Earth's crust. Some researchers even suggest that electromagnetic effects could alter the behavior of fluids within fault zones, But here's the crucial point. Even if these mechanisms exist, they would only affect faults that have already accumulated energy and are on the verge of rupturing. Space weather cannot create earthquakes out of thin air. At most, it could only hasten the timing of events that were already bound to happen. Tsunami science. The science of tsunamis that arise from these events requires special attention. The earthquake of July 29th became a real-world test case for a new generation of warning systems. NASA's Guardian system, which uses GPS technology to detect real-time ground movement, provided critical data within just minutes of the initial rupture. Combined with traditional seismic networks and ocean buoys, these systems painted an unprecedented picture of how energy propagated through both the solid Earth and the ocean above. The journey of the tsunami. The waves generated by the July event crossed the Pacific Ocean in less than 10 hours, offering a sobering reminder of the speed at which tsunamis can travel across ocean basins. Coastal communities from Alaska to Chile received early warnings, a testament to the international cooperation that has developed in tsunami science since the Indian Ocean disaster in 2004. Future outlook as we enter the remainder of 2025. Seismologists continue to monitor the Kamchatka region with particular interest. Statistical models suggest that more large aftershocks are still possible, with a probability that will decrease over the coming months and years. But here is something the traditional models do not account for. We are approaching a confluence of unique astronomical events unprecedented in recorded history. An interstellar comet and the solar cycle. An interstellar comet, with a tail stretching for hundreds of thousands of kilometers, is about to interact with the Sun, which is at the peak of its 11-year cycle. If the electromagnetic coupling between space weather and seismic activity is real, and that is a significant if, then the next few weeks could provide the most compelling test case we have ever had. The question is not whether the correlation is evidenced of causality, but whether the correlation is strong enough to warrant serious scientific investigation. Conclusion of Part 2. The Earth beneath Kamchatka remains in constant turmoil, its faults still adjusting to the immense pressure changes in the space weather environment on July 29th. It is becoming increasingly turbulent as solar cycle 25 approaches its peak, and somewhere in the darkness between the planets, Comet BA Atlas continues its ancient journey toward its rendezvous with our star. What happens when these three domains, geological, solar, and interstellar, converge within the same narrow window of time? The Kamchatka Peninsula may soon provide an answer, whether we are ready for it or not. 3 engines of earthquakes. The invisible river from the sun. There is something strange happening in the space around our planet that most people never think about. Right now, as you listen to these words, Earth is being bathed in an invisible river of charged particles flowing from the sun at a speed that could cross the continental United States. In less than 20 seconds, we call it the solar wind, and it has flowed past our planet for billions of years. But this river is anything but steady. Sometimes it rushes, sometimes it slows, and sometimes it creates conditions so unusual that a small group of researchers believe they can shake the very ground beneath our feet. Coronal holes. To understand this phenomenon, we need to talk about coronal holes. Imagine the sun's surface not as a uniform ball of fire, but as a complex magnetic landscape with open and closed field lines. Most of the time, magnetic fields emerge from the sun and loop back to the surface, trapping hot plasma in elegant arches that we see as solar active regions. But coronal holes are different. Here, the magnetic field lines shoot straight out into space, creating a magnetic highway for solar material to escape. The result is a high-speed stream of particles traveling at velocities that can exceed 700 kilometers a second. nearly double the speed of the normal solar wind. The solar wind vacuum. This is where things get interesting for researchers. Of earthquakes. When these high-speed streams sweep past Earth, they create what some scientists call a solar wind vacuum, a significant drop in particle density, sometimes dropping to less than 1 proton per cubic centimeter. To put that into perspective, the air you're breathing contains about 25 trillion molecules per cubic centimeter. The solar wind's vacuum is even more empty than the most perfect vacuum that we can create in a laboratory. The controversial hypothesis, according to a theory that has circulated in non-mainstream research circles, is that these vacuum conditions can do something extraordinary, causing large earthquakes from deep within the Earth. The theory goes like this: the Earth's crust is under constant pressure from tectonic forces, with energy building up along fault lines until it finally ruptures. But what if external electromagnetic fields could influence the timing of that rupture? What if the electrical environment surrounding our planet, modulated by solar wind conditions, could provide the small push needed to trigger earthquakes that are already loaded and ready to fail? The proposed mechanism involves a chain of electromagnetic effects. These high-speed solar wind streams create intense geomagnetic disturbances as they compress and stretch Earth's magnetosphere. These disturbances induce strong electrical currents in the planet's conductive layers, the ionosphere above and the conductive mantle below. These induced currents flow through the Earth's crust along paths of least resistance. This is a well-documented phenomenon that power companies monitor closely, as they can damage transformers and corrode pipelines. But could they also affect fault mechanics, triggering earthquakes? Now, in the field of mainstream research, this idea is not entirely absurd. Earthquake triggering is a vibrant field of study in mainstream seismology. Scientists know that small stress changes from tidal forces, shifts in atmospheric pressure, or even the extraction of groundwater can advance or delay the timing of earthquakes along faults that are near their breaking point. The question is whether electromagnetic effects are strong enough to make a difference. A natural experiment in September of 2025. In September of that year, we had the equivalent of a natural experiment, a persistent coronal hole named CH-1316 that directed high-speed solar wind toward Earth for several days. Solar wind observatories recorded the characteristic signature: a spike in velocity. The decreased density and sustained conditions created a prolonged geomagnetic disturbance. The subsequent G3 geomagnetic storm was not the strongest on record, but was notable for its extended duration and the specific electromagnetic conditions it produced. Ground-based magnetometers detected fluctuations lasting for more than 48 hours, while ionospheric monitoring stations registered disturbances that propagated globally. 3 days later, the Kamchatka Peninsula was shaken by a powerful 7.8 magnitude earthquake. Correlation does not prove causation. Correlation does not prove causation, and any scientist worth their salt will remind you of that fundamental principle. The earthquake occurred in a region that was already experiencing strong aftershock activity, following a powerful 8.8 magnitude event in July. From a purely statistical standpoint, large aftershocks are not only possible but expected, but it was the timing that captured the attention of researchers looking for potential connections. Their analysis suggested that large earthquakes tend to cluster during periods of low solar wind density, voids created by coronal hole streams. The proposed mechanism involves several steps. 1. The solar wind void reduces the external pressure on Earth's magnetosphere, allowing it to expand. 2. This expansion alters the geometry of the current systems that run through the magnetosphere-ionosphere coupling region. 3. These current changes modify the intensity and distribution of telluric currents flowing through the Earth's crust. In regions where fault systems intersect conductive geological structures, these current changes could theoretically alter pore fluid pressure, change the electrical properties of fault zone materials, or create stress concentrations that were not previously present. The effects would be minuscule on an absolute scale. But earthquakes are sensitive to small stress changes, when faults are already critically loaded. Research supporting these ideas comes from statistical analyses of earthquake catalogs, compared against space weather databases. Some studies report correlations between the intensity of geomagnetic storms and earthquake occurrence, while other studies find links with specific solar wind parameters like velocity and density. However, mainstream seismological science remains highly skeptical. The United States Geological Survey, which manages the world's most comprehensive earthquake database, states that no causal relationship has been established between space, weather, and seismic activity. Their position is supported by numerous independent analyses showing that reported correlations in some studies do not hold up when appropriate statistical controls are applied. The challenge in the research. The challenge in this field is to separate a true signal from a statistical artifact. Earthquake catalogs contain thousands of events, while space weather databases track continuous variations in dozens of parameters. With so many opportunities for comparison, finding apparent correlations is almost inevitable. Even if no real relationship exists, the issues pointed out, critics point to several problems. With space weather earthquake research, selection bias can influence which events and time periods researchers choose to analyze. The multiple comparisons effect means that testing dozens of potential correlations increases the likelihood of finding spurious relationships. The proposed physical mechanisms often lack quantitative support from laboratory experiments or theoretical calculations. The proponents' perspective. But proponents argue that the persistence of correlations reported across different regional datasets and analysis methods suggests that something real is happening. They point to documented cases where electromagnetic fields have influenced rock mechanics in laboratory settings, and the growing recognition that the Earth has a more complex and dynamic electrical environment than we once understood. The solar wind vacuum hypothesis. The solar wind vacuum hypothesis represents an attempt to provide a physical framework for these observations by focusing on a specific condition, a low-density, high-velocity solar wind stream from long-lasting coronal holes. It offers testable predictions about when space weather effects might be strongest, an opportunity for testing during solar cycle 25. As we pass through the peak of solar cycle 25, the opportunities to test these ideas are growing as coronal holes become more numerous and persistent during the solar maximum, creating high-speed streams that frequently interact. At the same time, geomagnetic monitoring has never been more comprehensive, providing detailed measurements of the electromagnetic environment throughout seismic events. The event series of September 2025 serves as a data point. The event series of September 9th, 2025 is a data point in this ongoing investigation. An extended coronal hole created the typical vacuum conditions. This was followed within days by a major earthquake in a region of seismic pressure. Whether this represents a causal correlation or a mere coincidence is still a matter of intense debate. The upcoming event is particularly fascinating, but the coming weeks are especially intriguing. We are not just dealing with normal solar activity. An interstellar visitor carrying a giant plasma halo is approaching its closest point to our star. If the electromagnetic connection between space and Earth is real, Comet Atlas may be about to provide the most dramatic test case in recorded history. In a broader sense, the solar wind vacuum is no longer just a curiosity for space physicists. It has become a potential gateway to understanding how our planet responds to the electromagnetic rhythm of the solar system. And as October 2025 approaches, That gateway is about to open much wider. In conclusion, whether you believe in earthquakes being triggered by space weather or not, one thing is certain: the coming weeks will provide a wealth of data for analysis. The question is whether that data will support the vacuum hypothesis or ultimately refute it. Either way, the Earth beneath our feet and the plasma coursing through our planet are about to engage in a cosmic dialogue that could reshape our understanding of how the solar system truly works. Part 4. The Planetary Alignment and the G3 Geomagnetic Storm. Sometimes the universe delivers such magical timing that even Hollywood screenwriters would be envious. On September 13th, 2025, Mercury reaches superior conjunction, a position directly behind the Sun as seen from Earth, forming a perfect straight line in space. Previously, this occurred 24 hours later, a G3-level geomagnetic storm struck Earth's magnetosphere with sufficient force to create beautiful green auroral curtains as far south as Kansas. Was it a coincidence? Mainstream astrophysics suggests it was entirely so. This storm was clearly caused by a high-speed solar wind stream from a coronal hole, and this feature had been tracked for days from its position 96 million kilometers away on the far side of the Sun. Mercury could not possibly influence solar wind conditions near Earth, but this is precisely where it becomes interesting for more unconventional researchers. Some scholars propose that the alignment of planets can have a subtle yet significant effect on the solar system's electrical environment, not through gravitational effects, which are far too weak, but through the complex web of electromagnetic interactions that connect all celestial bodies within the heliosphere. To understand this possibility, we need to imagine the solar system not as a collection of isolated worlds orbiting through empty space, but as one vast electrical circuit. The Sun at the center pumps out charged particles, creating electrical currents that flow throughout the heliosphere. The planets, with their magnetospheres and ionospheres, act like components within this circuit: resistors, capacitors, and inductors operating on a scale unmatched by human technology. When planets align within this electrical model, they can alter the total impedance of the heliospheric circuit. Think of it as adding or removing components in an electronic device. The currents shift, and the system responds in unpredictable ways. The Mercury conjunction on September 13th was particularly noteworthy because it occurred during a period of increased solar activity, as the Sun was approaching the peak of its 25th cycle, with a rising sunspot count and more frequent eruptions. Coronal. Hole. CH. 1316 had been sending high-speed solar wind toward Earth for several days, supplying the raw material for geomagnetic disturbances. Yet the storm on September 14th was stronger than many experts had predicted, with initial forecasts indicating a moderate G2 storm. But ground-based magnetometers registered a disturbance that reached a strong G3 level. The difference might seem small, but in terms of space weather, it represents a significant leap in electromagnetic energy. A G3 storm is the level at which space weather begins to have a noticeable impact on our daily technology, and the aurora becomes visible much farther, from the polar regions, with observers reporting sightings far to the south. In places like Colorado and Illinois, radio communications were disrupted, especially in the high-frequency bands used for aviation and maritime navigation. GPS accuracy decreased as ionospheric disturbances interfered with satellite signals. More importantly, for this investigation, the storms caused geomagnetically induced currents significantly in the Earth's crust. And these currents travel through conductive geological structures, following paths determined by mineralized groundwater and rock types. These currents themselves are well documented, as power companies have monitored them for many decades, because they can damage transformers and cause widespread power outages. The question is whether these currents are strong enough to influence seismic processes. Grid engineers worry about induced currents reaching hundreds of amperes in transmission lines. As some alternative researchers claim, millions of amperes might flow through the deep crust during major geomagnetic storms. The physical mechanism for how such currents could trigger an earthquake remains speculative, but several have been proposed. Currents flowing through a fault zone could alter pore fluid pressure by changing the electrochemical properties of groundwater, or they might modify the dielectric breakdown properties of the fault material, making slip more likely under existing stress conditions, or they could create localized heating, altering the rock strength along critical sections of the fault plane. Mainstream physics finds these mechanisms unconvincing, mainly because the energies involved seem too small to overcome the mechanical forces that control earthquake occurrence. A typical magnitude 7 earthquake releases energy equivalent to 32 nuclear weapons, whereas the electrical energy from even severe geomagnetic storms is only a fraction of that amount. But triggering an earthquake does not require matching the total energy of the seismic event. Small stress changes on the order of kilopascals, rather than megapascals, can advance the timing of an earthquake when a fault is already loaded near its breaking point. For example, tidal forces from the moon can trigger earthquakes, even though their mechanical effect is tiny compared to tectonic stresses. The key question is whether the electromagnetic effects from a geomagnetic storm can produce stress changes comparable to tidal triggering. Laboratory experiments suggest they can. Electric currents can influence rock fracturing processes, but applying this finding to natural fault systems remains challenging, which makes the storm of September 14th particularly interesting. Is its timing relative to both the Mercury conjunction and the subsequent Kamchatka earthquake? If planetary positions can modulate magnetospheric conditions, then alignment events might represent periods of enhanced electromagnetic coupling between space weather and terrestrial processes. The mechanism would work as follows. The planetary alignment alters the large-scale structure of the heliospheric current sheet, a vast spiral of electrical current, extending from the Sun's equator throughout the solar system. These changes propagate at the speed of light, reaching Earth in 8 minutes after being generated at the solar surface. When this altered magnetic field encounters Earth's magnetosphere during a geomagnetic storm, the interaction can be amplified compared to normal conditions. The planetary magnetic field funnels these enhanced currents into the polar regions, where they connect with the global circuit of telluric currents, which flow through the solid Earth in tectonically active areas like the Kamchatka Peninsula. In theory, these currents could provide the extra stress needed to trigger an earthquake on a fault that is already near its breaking point. The effect would be very small, perhaps advancing the timing of an earthquake by a few hours or days, rather than creating entirely new events. To test this hypothesis, careful statistical analysis of earthquake catalogs is needed against both geomagnetic storm records and planetary position databases. Some preliminary studies report weak correlations, but the scientific community remains divided on their significance. The September 2025 sequence of events provides one data point in this ongoing investigation. Mercury was at superior conjunction before Storm J3 by less than 24 hours. The storm itself lasted for more than 2 days, creating prolonged electromagnetic disturbances. 3 days after the storm began, the Kamchatka Peninsula experienced a magnitude 7.8 earthquake. Whether these events are connected by more than just coincidence remains an open question. The time lags involved, a few hours between the conjunction and the storm, and a few days between the storm and the earthquake, are consistent with the proposed electromagnetic triggering mechanisms. But they are also consistent with simple random coincidence, as we move deeper into the solar maximum. With solar cycle 25, the opportunities to test these ideas will multiply. Coronal holes become more common during the solar maximum, with the Sun creating frequent high-speed stream encounters. Planetary alignment events occur regularly throughout the year, offering many chances to compare electromagnetic conditions. The real test may come in late October, when Comet Atlas reaches perihelion while several other astronomical events occur simultaneously. If the electromagnetic link between space weather and earthquakes is real, this period could provide the most compelling evidence ever discovered. But that is when the effects remain subtle and localized. What if they are not? What if the electromagnetic environment during the October alignment is strong enough to influence seismic activity across multiple regions at once? We are about to enter uncharted territory in the relationship between space weather and terrestrial processes. The Sun is more active than it has been in years. Multiple comets are converging in the inner solar system, and the positions of the planets are creating conditions unprecedented in recorded history. The September events may have been just a prelude to a much larger cosmic drama, and whether that drama will unfold as a scientific curiosity or something more significant depends on the questions we are only now beginning to learn how to ask. Part 5. The Antipodal Threat. There is an elegant symmetry to our planet that most people never consider. Draw a line from any point on the Earth's surface, through its center and out the other side, and you will find its antipodal point, the exact opposite location on the globe. For most locations, the antipodal point lies somewhere in the middle of an ocean, but for the seismically active Kamchatka Peninsula, something more interesting emerges. Its antipodal point falls very close to the Elben Drag, one of the most tectonically active regions in the Southern Ocean. This geographical curiosity has captured the attention of researchers who study the so-called energy balance in the global seismic system. Their hypothesis is provocative and largely unproven. When large earthquakes occur, they create a stress imbalance that must eventually be resolved, and sometimes that resolution occurs halfway around the world. This concept is based on both established physics and geodynamic speculation. We know that large earthquakes generate seismic waves that propagate throughout the Earth. These waves, particularly the long-period surface waves, can travel around the globe multiple times, carrying information about the magnitude, depth, and fault characteristics of the earthquake to every point on the planet's surface. But what if they carry something more? What if they transmit stress changes that actually accumulate over time, setting the stage for future earthquakes in locations that seem completely unrelated to the initial event? The Kamchatka earthquake of July 29th, with a magnitude of 8.8, certainly generated enough energy to test this hypothesis. Seismic waves were recorded by monitoring stations on all 6 continents, with instruments detecting the motion for more than 12 hours after the initial tremor. The waves circled the Earth multiple times before finally dissipating into the constant background noise of seismic activity. In the process, they passed through every major fault system on the planet, including the complex network of transform faults, mid-ocean ridges, spreading centers, and subduction zones that encircle the Southern Ocean. The Elben Trick region is particularly sensitive because it lies at the intersection of 3 major tectonic plates, the Antarctic, South American, and Scotia plates, creating a zone where stress can build and release in unpredictable ways. The antipodal hypothesis suggests that energy from the Kamchatka earthquake may have been deposited in these Southern Ocean structures, priming them for a delayed seismic response. The mechanism is not clearly defined, possibly involving direct stress transfer through the Earth's deep layers, resonance effects that amplify local stress concentrations, or more exotic processes involving the planet's magnetic field and conductive structures. What makes this idea particularly compelling to its proponents is the time frame they have identified. based on historical analysis of supposed antipodal earthquake pairs. They suggest the delayed response typically occurs within 26 months of the initial event, which, for the July 29th Kamchatka earthquake, puts us squarely in that window as we move through October and November of 2025. But this is where a dose of healthy skepticism is warranted. Mainstream seismology does not recognize triggering, antipodal seismic activity is a validated phenomenon. The United States Geological Survey and other authoritative bodies forecast earthquakes based on local geological conditions, the rate of stress accumulation, and statistical models derived from regional seismic history. Global stress transfer is real. It is well-established science. Large earthquakes alter stress conditions over thousands of kilometers, and these changes can accelerate or delay the timing of earthquakes along connected fault systems, but the effect typically diminishes rapidly with distance, following a well-understood mathematical relationship based on fault geometry in the Earth's crust. Antipodal triggering would require transferring energy through 12,700 kilometers of solid Earth, the maximum possible distance between any 2 points on the planet's surface. Although seismic waves certainly travel these distances, the idea that they can focus enough stress to trigger major earthquakes remains highly speculative. The challenge lies in the energy budget calculation. An 8.8 to 10 magnitude earthquake releases approximately 10 to the power of 17 joules of energy, equivalent to roughly 32 megatons of TNT, but most of that energy is dissipated as heat and seismic wave radiation within the first few hundred kilometers of the rupture zone. The fraction of energy that reaches antipodal distances is minuscule compared to the local tectonic forces that control earthquake occurrence. However, proponents of the antipodal triggering hypothesis point to several examples that seemingly support the theory. The December 2004 Sumatra earthquake was followed 4 months later by a magnitude 8.6 event on the same fault system. The March 2011 Tohoku earthquake preceded unusual seismic activity in several antipodal regions. Although no major events clearly fit the predicted pattern, more intriguingly, some researchers have identified apparent correlations between earthquake swarms in the Pacific Ring of Fire and simultaneous activity along the Mid-Atlantic Ridge System. These correlations, if real, would suggest a global-scale stress transfer mechanism that traditional seismology does not fully understand. The Drake Passage region is a particularly interesting test case because of its unique geological setting. This strait is the youngest ocean gateway on Earth, having opened only 34,005 years ago, when South America and Antarctica finally separated. A relatively recent event in geological history. This means the fault systems here are still adjusting to the new configuration. This region experiences frequent seismic activity along the Antarctic-South American ridge, with typical events ranging from magnitude 5 to 7, but the complex interaction between spreading ridges, strike-slip faults, and the nearby South Sandwich region creates conditions where larger events could still occur. If antipodal energy transfer is real, we might expect to see some signs in the Drake Passage region in the coming months, as increased seismic activity across multiple fault systems would indicate a widespread stress change, rather than a localized impact. Changes in earthquake focal mechanisms, the orientation of fault planes, could indicate that the stress field has shifted, and the timing of any large events would need to fall within the predicted time frame for an antipodal response. The electromagnetic component of this hypothesis adds another layer of complexity. Some researchers propose that antipodal earthquake triggering is not purely mechanical, but also involves electrical effects propagating through the Earth's conductive layers. This idea connects the concept of seismic energy balance with the broader electromagnetic theories we have explored. According to this electromagnetic variation, the Kamchatka earthquake not only created mechanical stress changes but also electrical disturbances that propagated through the planet's conductive mantle and core. These disturbances, in theory, could influence seismic processes in the antipodal region through mechanisms similar to those proposed for space weather, causing changes in pore fluid pressure, altering the dielectric breakdown properties of fault materials, or creating localized thermal effects. The travel time for such electromagnetic propagation would be much faster than for mechanical stress transfer, which could explain some of the short-term correlations observed in historical earthquake catalogs. Electrical signals travel at a significant fraction of the speed of light through conductive materials, meaning that antipodal effects could appear within hours or days rather than months. Testing these ideas requires complex baseline analysis, global seismic data combined with electronic monitoring data. Some research groups have reported promising initial results, but the mainstream scientific community remains skeptical. The signal-to-noise ratio in global earthquake catalogs is challenging, and with many variables involved, it makes establishing a clear causal relationship difficult. What makes the current period particularly fascinating is the convergence of several potential triggering factors. We have the ongoing aftershock sequence from the July Kamchatka earthquake, heightened solar activity from solar cycle 25, and the approaching perihelion of Comet Atlas, with its immense electromagnetic flux, should antipodal triggering occur. The combination of these factors could be historic. The mechanical stress transfer from Kamchatka, the electromagnetic effects from space weather, and the potential interaction with the plasma environment of the visiting celestial body could theoretically combine to influence seismic processes across multiple regions at once. The Drake Passage is just one potential target in this scenario. Other antipodal points to regions that have experienced major earthquakes recently include parts of the Atlantic and Indian Oceans, where transform fault systems might be responsive to global stress changes. It is important to monitor for patterns of activity exceeding the norm, while staying within the predictive time frame as we move into October and November of 2025. Seismologists around the world will be monitoring these areas with particular interest, not because they necessarily believe in the antipodal triggering phenomenon, but because the convergence of so many unusual factors has created an unprecedented natural experiment. Whether that experiment will confirm alternative earthquake theories or reinforce conventional understanding remains to be seen. But the data collected during this period will undoubtedly contribute to the growing understanding of how the Earth responds to both internal and external sources of energy. The planet beneath our feet is a complex, interconnected system, where a change in pressure in one location can influence processes thousands of kilometers away. As we are about to discover, it may also be sensitive to influences from much farther away, including visitors from interstellar space. The energy balance hypothesis suggests that the Earth maintains a kind of seismic equilibrium, where large disturbances in one area will eventually trigger compensatory responses elsewhere. If that is true, then the Kamchatka earthquake in July created an imbalance, which still demands a resolution. The question is not whether that resolution will come, but where, when, and whether we will be ready to recognize it when it happens. 6 anomalous interstellar objects in the 1970s. Astronomer Carl Sagan once famously said, "We live in a universe where extraordinary claims require extraordinary evidence." By that standard, by 2019, Q4 Atlas presents us with quite a puzzle. This is not just an ordinary comet wandering through the solar system. It is a messenger from deep space, carrying the chemistry and materials forged in the stellar nurseries of distant suns. Its official name tells the story. The Y in BY 2019, Q4 stands for interstellar, and the number 3 indicates that this is the third confirmed visitor from outside our solar system. The first visitor was Oumuamua, which baffled astronomers when it appeared in 2017, with its cigar-like shape and mysterious acceleration. The second object, Borisov, appeared more conventional. Clearly, a comet that behaved as expected during its passage in 2019. By 2019, Q4 Atlas lies somewhere between the familiar and the extraordinary, and that is precisely what makes it so fascinating. Discovery and orbital characteristics. This object was first detected by the Atlas Terrestrial Impact Last Alert System in the year 2025. Appearing only as a faint dot moving against the backdrop of stars. But orbital calculations quickly revealed its true nature. This was not an asteroid or a common comet. Its orbit was clearly hyperbolic, indicating a speed and angle that could only come from a distant origin, beyond the sun's gravitational influence. Unusual activity. Initial observations showed something unusual about BLI. 2019 Q4 Atlas from the very beginning. Most comets remain dormant until they get within about 23 astronomical units of the Sun, the distance of the asteroid belt. But this interstellar visitor was already showing signs of activity at a distance where solar heat is almost negligible. The first detailed images from the Space Telescope, Hubble, confirmed what ground-based observers had suspected. Comet 2019 Y4. Atlas was developing its characteristic tail of gas and dust, giving it the distinctive appearance of a comet. But this tail was forming under conditions where conventional comet physics suggested it should not exist. Its coma structure was peculiar, and adding to the mystery were the morphological details that emerged from extended observation. Unlike typical comets, which develop a relatively symmetrical coma centered on the nucleus, Comet 2019 Y4. Atlas exhibited what astronomers call a forward brightening, or a leading coma structure. The brightest regions of the coma appeared ahead of the nucleus in its orbital motion due to rotational properties and surface characteristics unlike anything seen among local comets. Its chemical composition was unique, as spectral analysis revealed another surprise. While most comets in the solar system are primarily water ice with traces of carbon monoxide and carbon dioxide, Comet 2019 Y4 Atlas showed signs of an unusually rich abundance of carbon dioxide. This composition is significant for an object that formed in the frigid regions between the stars, where carbon dioxide gas remains frozen while water ice might be depleted by various processes. The colossal size of its coma truly set Comet 2019 Y4 Atlas apart. Estimates of the nucleus size, derived from Hubble observations and thermal modeling, suggested a relatively modest object, perhaps 3 to 6 kilometers wide. That is substantial, but not unprecedented in the world of comets. What was extraordinary was the size of the coma it produced. Current measurements indicate the surrounding envelope of gas. Comet 2019 Y4. Atlas stretched at least 348 kilometers from its center, creating a nearly spherical cloud with a diameter of about 700 kilometers. To put that in perspective, you could line up nearly 50 Earths side by side across the width of this coma, which makes Comet 2019 Y4. Atlas comparable in size to some of the largest structures in the solar system. The Sun itself has a diameter of about 1,400,000 kilometers, meaning this comet's coma spanned about half the width of the star, of our own. It is an ethereal, diffuse bubble of gas and dust drifting through space, with a scale that challenges our very intuition of what a comet should look like. The physical mechanism behind such a colossal coma from a relatively small nucleus involves several unique factors of interstellar objects, unlike comets from our solar system, which have been processed by billions of years of solar radiation and gravitational perturbations. 2I2019 Q4. Atlas represents pristine material from its original stellar environment. The mixture of ices it carries may be more volatile than anything we are familiar with, leading to enhanced outgassing. Even at great distances from the Sun, the object's rotation also plays a significant role. Preliminary observations suggest a rotation period of a few hours, typical for small bodies in the solar system. But the distribution of surface material may be very heterogeneous, with some regions rich in volatile ices, while other parts remain relatively inert. This patchwork structure could explain the asymmetric coma structure and the unusual brightening events that preceded its subsequent development. As 2I2019 Q4 Atlas approaches its perihelion on October 30th, the coma will almost certainly continue to grow. The increasing solar heat will sublimate more surface and subsurface ices, potentially expanding the coma to an even more impressive size. Currently, some models suggest that the gaseous envelope could reach a diameter exceeding 1 million kilometers, larger than the Sun itself. Its interaction with the space environment is what makes this phenomenon particularly fascinating. From a space physics perspective, it is all due to the gigantic gaseous envelope. It is not just a passive cloud of gas and dust. It is an electrically active plasma structure, interacting with the solar wind and the interplanetary magnetic field in ways we have never had the opportunity to study, as solar wind particles collide with the neutral atoms and molecules in the cometary coma. They can strip away electrons, creating ions that react to electromagnetic forces. These newly created ions are then swept up by the solar wind and carried away, forming the characteristic ion tail that points away from the Sun. The object acts as a natural probe of the space environment, with a coma stretching for hundreds of thousands of kilometers. This interaction zone becomes truly enormous. 2I2019 Q4 Atlas is essentially dragging a spherical net through the solar wind. Through the solar wind, a sensitive net, to variations in magnetic field strength, particle density, and plasma temperature. It has become an interstellar probe of heliospheric conditions, reacting to space weather in ways that could provide unprecedented insights into the electromagnetic environment around the Sun. The ideal observation time. The timing of its arrival was perfect for scientific study. Solar cycle 25 is approaching its peak activity with an increase in solar flares, coronal mass ejections, and high-speed wind streams, and the corona is more dynamic and turbulent than it has been in over a decade, providing 2I2019 Q4 Atlas a wide variety of plasma conditions to sample and react to, offering diverse scientific observations. NASA's James Webb Space Telescope has tracked the object's spectral evolution, while ground-based observatories monitor changes in the coma's morphology and tail development. The European Space Agency's Solar Orbiter mission is positioned to provide complementary measurements of the solar wind as 2I2019 Q4 Atlas encounters different regions of the active heliosphere. Natural plasma experiment. What we are witnessing is essentially a controlled experiment in plasma physics on a scale that cannot be replicated in any laboratory, where an object from another star system is acting as a probe of our local space environment, revealing details about magnetic field structures and particle interactions that would otherwise be invisible. The broader implications. 2I2019 Q4 Atlas represents more than just a scientific opportunity. It is a reminder that our solar system is not isolated from the galaxy around it. Objects drifting between stars regularly carry with them the chemical signatures and physical processes of distant stellar neighborhoods. We are sampling extrasolar material, and extrasolar physics delivered right to our cosmic doorstep. The potential to influence space weather. The question some researchers are beginning to ask is whether 2I 2019 Q4 Atlas might carry more than just scientific interest. Its enormous electromagnetic footprint and its strange interactions with solar wind conditions have prompted speculation about whether such objects could affect space weather in measurable ways. That speculation leading to some incredibly strange possibilities about what these interstellar visitors might represent and what they might be capable of during their brief passages through our solar system. Currently, 2019 Q4 Atlas continues its ancient journey, heading toward its appointment with the Sun, growing brighter and more active with each passing day. Whatever secrets it holds about its distant origins, it is about to share them with us in the most dramatic way possible. The universe has sent us a messenger from interstellar space, and the only question is whether we are ready to understand what it is trying to tell us. A coma half the diameter of the Sun. Imagine a soap bubble floating in space, but one so vast you could fit 25 Earths inside it with room to spare. That is the scale we are talking about when we speak of the coma of Atlas. 2019 Q4 Atlas, a fragile shell of gas and dust that has grown to a size that defies our understanding of what a comet can become. A colossal scale. The latest measurements from infrared space telescopes have painted a picture that seems almost unbelievable. The cometary coma extends at least 348,000 kilometers in radius from the object's nucleus, creating an active sphere about 700,000 kilometers wide. To put that in cosmic perspective, this interstellar visitor has created a bubble spanning more than half the diameter of the Sun. The comparison to the Sun, that comparison is not just a curious astronomical fact. It is a window into the physics at play on scales we rarely encounter. The Sun is a giant ball of plasma held together by its own gravity, generating temperatures of millions of degrees at its core. 2019 Q4 Atlas is a tiny piece of ice and rock, perhaps no larger than a small mountain, creating a structure of immense size comparable to our Sun, through entirely different processes. The nature of a cometary coma. The key to understanding this phenomenon lies in the nature of cometary comas. When we see a comet in the night sky, that glowing head is not the solid nucleus, it is the cloud. Gas and dust particles have been released from the surface due to heating from the Sun, as the frozen ices sublimate directly from a solid to a gaseous state. They carry dust particles with them, creating an expanding envelope around the nucleus. For most comets in the solar system, this process begins gradually as they cross inside the orbit of Jupiter, and at about 5 astronomical units from the Sun. The coma typically reaches its maximum size around perihelion, its closest point to the Sun, before slowly dissipating as the object moves back toward the outer solar system. This early activity is unusual, but C 2019 Y4 Atlas was breaking all the conventional rules. It began to show cometary activity while still beyond 38 astronomical units from the Sun. At a distance where solar heating is almost negligible, this early onset of activity suggested that the object carried much more volatile ices than the typical water ice that dominates solar system comets. Its unusual chemical composition, revealed by its spectral signature, tells part of the story. Unlike local comets, which are predominantly water ice, with minor amounts of carbon monoxide and carbon dioxide. C 2019 Y4 Atlas showed a composition rich in carbon dioxide and other exotics. These materials sublimate at much lower temperatures than water, which explains how this object could sustain such a massive coma. While still relatively far from the Sun, carbon dioxide ice begins to sublimate at around -78 degrees Celsius, under Earth's atmospheric pressure. But in the near vacuum of space, sublimation can occur at even lower temperatures, driven by the faint heat of the distant sunlight. This means that C 2019 Y4 Atlas had been continuously outgassing for many months as it approached perihelion, building up its enormous atmosphere particle by particle, the complex structure of the coma. But the size alone doesn't capture the full strangeness of this structure. The coma is not a uniform sphere of gas and dust. It is a complex, dynamic environment, where multiple physical processes occur simultaneously. Solar radiation pressure pushes small dust particles away from the sun, creating the characteristic dust tail that can stretch for millions of kilometers behind the comet. Meanwhile, the solar wind, a stream of charged particles flowing from the sun at 400 kilometers per second, interacts with the neutral gas in the comet's coma through a process called photoionization. This process of ionization occurs when high-energy photons from the sun strike neutral atoms and molecules. They can knock electrons loose, creating ions that suddenly become responsive to magnetic fields. These newly created ions are then swept up by the solar wind and carried away from the comet at tremendous speeds, forming the blue ion tail that always points directly away from the sun, regardless of the comet's motion. This creates a giant plasma net around the object, with its coma stretching for hundreds of thousands of kilometers. This ionization process creates a vast region of chemically active plasma. Imagine C 2019 Q4 Atlas as pulling a giant net through the solar wind, a net that constantly samples the electrical environment. From around the sun, variations in the solar wind speed, density, and magnetic field all affect how the comet responds. During periods of enhanced solar activity, like the geomagnetic storms we have experienced, the interaction becomes more complex and more energetic. The phenomenon of forward brightening observed in C 2019 Q4 Atlas adds another layer of complexity to this picture. Most comets develop relatively symmetrical comae, centered on the nucleus. But this interstellar visitor showed its brightest regions, ahead of the nucleus in its orbital direction. This asymmetry suggests that the outgassing process is concentrated in specific regions on the surface, possibly due to the object's rotation or a non-uniform composition. As Atlas rotates, different surface areas face the sun, leading to periodic outgassing, which creates structures within the coma. The rate of mass loss, the scale of this activity, becomes truly impressive. When we consider the associated mass loss rate, current estimates suggest that C 2019 Q4 Atlas was losing several kilograms of material every second as it approached perihelion. That may not sound like much, but sustained over many months, it represents thousands of tons of pristine interstellar material being dispersed throughout the inner solar system. This is an interstellar chemical sample. This material carries the chemical signature of the environment where C 2019 Q4 Atlas formed billions of years ago. Spectroscopic analysis of the comet provides a direct sample of interstellar chemistry, offering insights into the conditions around other stars that we could never obtain by any other means. An unprecedented electromagnetic phenomenon, but this comet represents so much more. Not just a scientific opportunity, it is also an electromagnetic phenomenon of unprecedented scale. The ionized component of the coma creates a vast region of space where plasma physics operates under conditions that we have never been able to study before. The interaction between this plasma and the local magnetic field environment could theoretically affect space weather conditions throughout the inner solar system. Some researchers have begun to speculate whether passing objects, like 2019 Borisov and Atlas, could act as natural space weather regulators. Their giant comas act as plasma reservoirs that can amplify or dampen electromagnetic disturbances. This idea is still very much speculative, but the sheer scale of the interaction region makes it worth considering. The expansion continues as we approach perihelion on the 30th of October. The coma will almost certainly continue to grow. Increasing solar heat will vaporize. More surface ice, potentially expanding. The coma to a size exceeding the diameter of the Sun. Some models suggest that the peak coma size could reach 2 million kilometers, creating a structure larger than any permanent structure in the solar system, except for the Sun itself. Limited observability. The ability to observe this enormous structure from Earth remains limited. Unfortunately, despite its impressive size, the coma is extremely diffuse, with a particle density much lower than Earth's atmosphere. At great distances, most of the mass is concentrated in the dust tail, which may become visible to skilled observers using telescopes as the object orbits the Sun. Multi-wavelength observations. But the real drama is unfolding. At wavelengths invisible to the human eye, radio telescopes are detecting emissions from the coma's ionized component, while infrared satellites track the thermal signature of the dust particles heated by sunlight, and X-ray observatories monitor the high-energy processes in the interaction zone between the comet and the solar wind, a natural plasma laboratory. What we are witnessing is a lesson in physics, plasma being taught by a visitor from another star. 2I 2019, Q4. Atlas has created a natural laboratory to study electromagnetic interactions on a scale impossible to replicate on Earth, revealing details about how matter and energy behave in the space environment around the Sun. The question of an active role. The question now beginning to arise from all these observations is whether 2E 2019 Q4 Atlas could be more than just a passive block of ice and rock, wandering through space, whether an object capable of generating a signature so massive and electromagnetic could actually influence the space weather conditions it is sampling. That possibility leads us into a realm that is both science and science fiction, where the boundary between natural phenomena and technological possibility begins to blur in ways that challenge our assumptions about what is possible in the universe. Part 8. What if 2I Atlas were an alien energy harvesting machine? Let's step into the realm of pure speculation for a moment. A hypothesis, grounded in physics, that might not be as far-fetched as it first seems. What if 2I Atlas were not merely a pristine block of ice and rock from another star system? What if it were something far more extraordinary? A vast, energy-capturing device crafted by an intelligence we can barely imagine, designed to harvest energy from stars as it travels between solar systems. This idea may sound like science fiction, but consider the evidence we've discussed. A relatively small nucleus, perhaps 3 to 6 kilometers wide, generates a coma that spans 700 kilometers. That's a ratio of efficiency that would be the envy of any engineer. A structure less than 6 kilometers wide, creating a zone of activity more than 100 times its size. From an energy-gathering perspective, that vast cloud begins to look less like random outgassing and more like a purposefully engineered plasma sail. Imagine a technology that could deploy a gossamer thin mesh made of conductive material, a mesh that unfurls to an enormous size, while maintaining the ability to channel the captured energy back to a central processing core. Physically, it's not impossible. We already know that. Electric fields can accelerate charged particles to enormous velocities. That is the principle behind plasma engines and magnetic confinement fusion. What if 3I/Atlas represented an advanced version of these technologies designed to operate in the natural plasma environments surrounding stars? The forward brightening that we observed could represent an active guidance system, rather than random surface features, if the object is using controlled outgassing to alter its trajectory, or optimize its interaction with the solar wind. we would expect to see, precisely, the kind of asymmetric activity that has puzzled astronomers. The abundance of CO2 takes on a new significance in this context. Unlike water, which requires high temperatures to sublimate, carbon dioxide can turn directly from a solid to a gas at the low temperatures of deep space. This makes it an ideal propellant for a system that needs to operate over the vast interstellar distances. The energy harvesting mechanism. The collection of energy would require more than just a large plasma interaction region. It would need some mechanism to channel the captured energy for useful purposes. This is where the physics gets interesting. The same processes that create a comet's ion tail could, in theory, be harnessed to generate electrical currents on a massive scale. When solar wind particles ionize neutral atoms in the coma, they create charged particles that interact with the magnetic fields in a natural comet. These ions are simply swept away by the solar wind. But what if 3I/Atlas contained embedded magnetic field generators that could guide these ions along specific pathways? Such a system could function as a generator, a vast magnetohydrodynamic generator, converting the kinetic energy of the solar wind particles into electrical current. The scale would be unprecedented. We are talking about an energy collection area measuring millions of square kilometers, operating in an environment where particle velocities routinely exceed 500 kilometers per second. The energy budget is impressive. It becomes staggering when you do the math. The solar wind carries about 4 watts per square meter at Earth's distance from the Sun, with an interaction cross-section the size of a comet's coma. For BAI Atlas, that would mean the potential to harvest energy in the terawatt range, equivalent to hundreds of the large power plants. Of course, conversion efficiency would be critical, as natural plasma interactions are notoriously inefficient, with most of the energy being dissipated as heat and electromagnetic radiation. But an engineered system could achieve efficiencies that nature cannot by using superconducting materials or exotic magnetic field configurations to maximize energy capture. The question then becomes what such a system would do with the captured terawatts of energy. One possibility is energy storage, perhaps through the creation of exotic states of matter or particle configurations of high energy that could be sustained in interstellar space. Another possibility is active propulsion, using the captured energy to accelerate reaction mass and alter the object's trajectory through space. From a strategic perspective, a stellar energy harvesting device would make sense for any civilization attempting to explore or colonize the galaxy. Stars are the most concentrated energy sources available, and a technology that could efficiently tap into stellar energy would offer a tremendous advantage for interstellar travel. Such devices could serve multiple functions: energy collection, propulsion, communication, and scientific exploration. They could operate autonomously for millions of years, following pre-programmed routes between star systems while gathering data and resources. For their creators, the concept of the von Neumann probe, proposed by mathematician John von Neumann in the 1940s, describes self-replicating machines that could spread throughout the galaxy by gathering materials and energy from the star systems they encounter. BAI Atlas could represent a more sophisticated version of this concept, not self-replicating, but self-sustaining through stellar energy harvesting. But this is where we need to apply some critical thinking. If BAI Atlas were artificial, we would expect to see clear signs that distinguish it from a natural object: unusual spectral lines, non-thermal radiation, or orbital changes that cannot be explained by gravity and outgassing forces. So far, most observations of BAI Atlas seem consistent with the natural behavior of a comet, although on an unusual scale, the spectral signature shows atomic and molecular lines, expected from sublimating ice. The trajectory follows a hyperbolic orbit, which could be the result of a gravitational push from another star system. the non-gravitational acceleration observed in some comets, including Oumuamua, could theoretically be the result of an artificial propulsion system. But it could also be explained by asymmetrical outgassing or other natural processes that we do not yet fully understand. The critical test is the detection of technosignatures, artificial materials, coherent electromagnetic emissions, or systematic behavioral patterns that indicate deliberate control. Radio telescopes searching for signals from BAI Atlas have so far found nothing but the expected natural emissions from plasma interactions. Perfect mimicry. However, the absence of artificial signatures clearly does not necessarily rule out advanced technology. A sufficiently sophisticated civilization could design their probes to mimic natural phenomena, avoiding detection by less advanced species they encounter on their journey. This mimicry could serve several purposes. Scientific, to avoid contaminating observations of natural systems. Strategic, to prevent interference with local civilizations. Or protective, to avoid revealing the probe's true capabilities to potentially hostile species. From this perspective, the apparent naturalness of BAI Atlas could actually be evidence of its artificial origin, a technology designed to harness stellar energy, while remaining undetected, would need to perfectly mimic the behavior of natural interstellar objects. The timing of its arrival during solar cycle 25 could be coincidental, or it could represent optimal conditions for energy harvesting. A sophisticated probe might time its perihelion passage to coincide with post-maximum activity phases, when solar wind conditions provide the richest energy environment. Electromagnetic effects and space weather. The electromagnetic effects we have explored throughout this investigation take on new meaning in this context. If BAI Atlas is actively harvesting solar energy, it could generate electromagnetic signatures that could affect space weather within the solar system. These effects could be intentional, perhaps designed to test the reactive properties of the planetary magnetosphere, or simply the unavoidable consequence of energy harvesting processes operating on a massive scale within the heliospheric environment. The earthquake correlations we have examined may suggest a sensitivity to these electromagnetic signatures rather than a reaction to natural space weather variations. If BAI Atlas is modulating local space weather conditions through its energy harvesting activities, systems on Earth might react in ways that seem mysterious when we only assume natural causes. More strangely, this hypothesis leads us to even more bizarre possibilities. What if the triggering of earthquakes is not a side effect, accidental to extraterrestrial energy extraction, but a deliberate test of the planet's seismic system? BAI Atlas could be conducting a systematic survey of Earth's geological response to electromagnetic stimulation. This idea takes us far beyond conventional scientific thinking and into territory that most researchers would dismiss as pure fantasy. But as we will explore next, the possibility of directed energy effects, whether natural or artificial, raises profound questions about the nature of the phenomena we have been investigating. Whether BAI Atlas is an ancient block of ice or a masterpiece of alien engineering, its passage through our solar system represents an unprecedented opportunity to observe plasma physics on a scale we have never before encountered. The question is, are we prepared to recognize what we are seeing, whatever it may ultimately prove to be? Part 9: Earthquakes as a Directed Energy Source. This is where our investigation enters territory that would have most seismologists reaching for their blood pressure medication. What if the earthquake patterns we are tracking are not random geological events responding to natural space weather? What if they represent something far more unsettling, directed energy effects, systematically probing the reactive properties of the Earth's crust with the precision of a controlled experiment? At first, this idea might sound far-fetched, but let's consider the patterns we have established. High-speed solar wind streams create a low-density vacuum environment, an environment that some researchers believe can trigger earthquakes on stressed fault systems. The temporal correlation is suggestive, even if the physical mechanisms remain disputed by mainstream science. But what if those vacuum conditions were not entirely natural? What if an advanced technology could modulate the properties of the solar wind, creating precisely the necessary electromagnetic conditions to influence seismic activity on a planetary scale, redefining energy and information? This concept requires thinking about energy and information on scales that challenge human intuition. We are accustomed to earthquakes as chaotic events, unpredictable, driven by the slow accumulation of tectonic stress over many decades or centuries. The idea that they could be triggered by external electromagnetic fields seems to contradict everything we know about the mechanics of rock. However, the energy calculations are not as impossible as they might first appear. Large earthquakes release a colossal amount of energy, equivalent to hundreds of nuclear bombs. But that energy is already stored in the system due to tectonic loading. Triggering it does not require matching the total energy output. It simply requires providing the small bit of extra stress needed to initiate the rupture on faults that are already critically stressed. Laboratory experiments have demonstrated that electromagnetic fields can influence the process of rock fracture under controlled conditions. Electric currents passed through rock samples can alter their mechanical properties, changing the pore fluid pressure or creating local heating, affecting the failure threshold. The question is whether these laboratory-scale effects can be scaled up to influence natural fault systems' planetary research through triggered experiments. If an advanced technology wanted to study planetary seismic systems, systematic triggering experiments would provide invaluable data. By creating controlled electromagnetic conditions and observing the resulting seismic responses, such a system could map the stress state of faults, the structure of the Earth's crust and stress transfer mechanisms with unprecedented accuracy. The historical record provides some interesting data points for this speculation. When Oumuamua made its closest approach to the Sun in September 2017, Mexico experienced a devastating earthquake of magnitude 8.2 just days later. The Tohoku earthquake in March 2011 occurred during a period of increased solar activity, with several significant geomagnetic storms in the weeks leading up to the event. These correlations don't prove anything, of course, as earthquakes happen frequently, and space weather events are also common during periods of solar maximum. Finding correlations between astronomical events and seismic activity is almost inevitable when you look at the data over many decades. But the patterns become more interesting when you consider the global distribution of major earthquakes during periods of unusual astronomical activity. The 2004 Sumatra earthquake, the 2010 Chile event, the 2011 Japan disaster, all occurred during solar cycles characterized by heightened space weather activity, unusual precursors. What's more interesting is that some of these events showed anomalous precursors suggesting an external trigger, rather than purely tectonic causes. Changes in groundwater levels, electromagnetic anomalies, and atmospheric disturbances began days or weeks before the main event. All of these phenomena could theoretically be the result of systematic electromagnetic probing of the crustal layers. If Comet Atlas represented an advanced probe rather than a natural comet, its massive electromagnetic footprint would provide an ideal platform for conducting such experiments. The object's enormous coma created a plasma interaction region larger than most planets. A system could theoretically conduct and focus electromagnetic effects over millions of kilometers of space. The magnetic field manipulation technology, the technology required would not necessarily violate known laws of physics. Controlled magnetic fields using superconducting coils can create focusing effects, which concentrate electromagnetic energy at specific planetary locations, and full plasma systems can adjust the properties of the solar wind, creating vacuum conditions that some researchers associate with the triggering of earthquakes. The precise timing that we have observed between space weather events and seismic activity may reflect a sophisticated understanding of crustal loading cycles and stress accumulation patterns. An advanced monitoring system could continuously track fault conditions, waiting for the optimal moments when small electromagnetic disturbances could trigger large-scale responses. Such a system could operate through multiple simultaneous mechanisms. High-frequency electromagnetic pulses could alter the electrical properties of fault-zone materials. Low-frequency magnetic field variations could generate eddy currents, altering fluid pressure. Plasma and ionospheric injections could create atmospheric pressure waves that propagate downward to influence the crustal stress field. The targeting would not need to be perfectly precise. Fault systems are complex, interconnected networks, where a stress change in one location can cause cascading failures over hundreds of kilometers. A technology that could create widespread regional electromagnetic anomalies might be sufficient to influence seismic activity without requiring absolute precision. The motive behind the experiments. But why would an advanced civilization want to do this? For such experiments, the motivation could range from pure scientific curiosity to more practical considerations of planetary habitability and resource distribution. An understanding of the seismic system would be crucial for any civilization considering planetary colonization. Earthquakes reveal information about the planet's crustal structure, resource distribution, and long-term geological stability. A comprehensive seismic survey could identify optimal locations for infrastructure development, while avoiding areas prone to catastrophic geological activity. From a more sobering perspective, the ability to induce earthquakes would represent an ultimate strategic capability, the power to devastate coastal cities or disrupt critical infrastructure through remote electromagnetic manipulation would offer immense leverage in any interplanetary diplomatic scenario. The ethical implications, they are truly immense. If major earthquakes could be artificially triggered, the humanitarian consequences would be incalculable. The Indian Ocean tsunami in 2004 claimed the lives of nearly 250,000 people. The Tohoku disaster in 2011 led to multiple nuclear meltdowns. The thought that such events could be the result of alien experiments is almost too horrifying to contemplate. Yet this possibility forces us to confront uncomfortable questions about the nature of the phenomena we have observed. The correlation between space weather and seismic activity, the unusual temporal patterns, the unprecedented convergence of astronomical events during solar cycle 25. All could be interpreted as evidence of a systematic investigation, rather than random coincidence. The challenge in distinguishing lies in differentiating between deliberate actions and natural phenomena that we do not yet fully understand. Advanced plasma physics, operating on a heliospheric scale, could produce effects that seem artificial when observed from our limited perspective. Natural interactions between massive cometary clouds and solar wind conditions can generate electromagnetic signatures that mimic technological systems. The key challenge is to detect patterns that indicate intelligence and intent, rather than natural variation. The systematic targeting of specific fault systems. The precise timing correlates with optimal stress loading conditions. The electromagnetic signatures suggest technological characteristics rather than natural ones. So far, the seismic patterns we have observed remain within the range of natural variation, even if their timing relative to space weather events is suspicious. The Kamchatka Peninsula has experienced major earthquakes in a region already, under seismic stress from tectonic processes that have been ongoing for millions of years. A definitive test But the perihelion passage of airless in October could provide a more decisive test. If the object represents advanced technology rather than a natural comet, then its closest approach to the Sun could coincide with enhanced electromagnetic effects, which could influence seismic activity in measurable ways. The global seismic monitoring network has never been more comprehensive than it is today. An earthquake with a magnitude above 4 on the Richter scale is detected within minutes by multiple observatories, providing unprecedented resolution and timing, location, and source mechanism. If there is a directed energy effect, the October period will reveal patterns that clearly distinguish them from natural seismic processes. Electromagnetic monitoring capabilities are equally sophisticated, with a network of magnetometers spanning the globe, while satellite systems provide continuous measurements of space weather conditions. Throughout the heliosphere, any technological manipulation of electromagnetic fields would leave a distinguishable signature from the natural variations of the Sun and Earth's magnetic field. The implications for our understanding. The unsettling aspect of this speculation is not just the possibility that earthquakes could be artificially triggered, but what it would imply about our understanding of the cosmos around us. The discovery that major geological events could originate from extraterrestrial technology would fundamentally challenge our assumptions about planetary security and our place in the cosmic community. It would suggest that civilizations advanced enough for interstellar travel might view Earth-like planets as natural laboratories suitable for experiments, potentially causing large-scale humanitarian disasters for the inhabitants. The ethical frameworks governing such activities would perhaps be as alien as the technology itself. From a more optimistic perspective, systematic seismic monitoring could represent a form of planetary survey, gathering data on the structure of the Earth's crust and geological processes that could prove valuable for future scientific collaboration. The triggering effects, if real, could be an unfortunate but unintentional consequence of legitimate scientific research. The truth is, we simply do not know enough about the physics involved to make a definitive judgment about what is natural and what might be artificial. The electromagnetic interaction between giant cometary halos and the coronal plasma is a pioneering scientific field, where our theoretical understanding remains incomplete. What we can do is continue to monitor the situation with the most sophisticated instruments at our disposal, observing for patterns that might reveal the true nature of what we are observing. The coming weeks will provide data that could reshape our understanding of how the solar system functions as an interconnected electronic environment. Whether that data supports natural explanations or points toward more exotic possibilities, it will contribute to our knowledge of phenomena operating on scales far beyond anything we can replicate in our laboratories on Earth. Ultimately, the universe is conducting experiments that we are only just beginning to learn how to observe and interpret. The question is not whether directed energy effects are real, but whether we are sophisticated enough to recognize them if they are. As the three Atlas approach their rendezvous with our Sun, we are about to get our most comprehensive view yet of plasma physics in action on a truly cosmic scale. If what we see challenges our assumptions about what is possible in the natural universe, we will need to be prepared to expand our understanding in ways that might cause us to fundamentally reconsider our place in the galaxy around us. Part 10. The October Convergence and the Unknown Risks. October 2025 is shaping up to be one of the most significant astronomical periods in history, marking a convergence of celestial phenomena that reads like an excerpt from an ancient apocalyptic text. But unlike the fevered imaginings of doomsday prophets, these are real astronomical phenomena that can be precisely calculated and scientifically verified. The question is not whether they will happen, but what they mean for our planet and our understanding of how the solar system truly operates. The focal point of this cosmic convergence is the new moon on the 21st of October, when Earth's natural satellite will align directly between our planet and the Sun. This in itself is not unusual, as new moons occur monthly with clockwork precision. But this particular new moon coincides with several other significant astronomical events, creating conditions we have not seen in recorded history. Comet BAE Atlas reaches perihelion on the 30th of October, its closest approach to the Sun at about 1.4 astronomical units, which is still outside Earth's orbit, farther than Mars at its closest, but near enough for the object's massive coma to interact profoundly with the solar wind conditions, which are growing increasingly turbulent as solar cycle 25 approaches its peak. Meanwhile, Comet C2022E1 Rice will make its closest approach to Earth around the 19th to the 21st of October, just 0.26 astronomical units from our planet, which is about 1/4 of the distance between Earth and the Sun. Close enough that its developing tail stretches several degrees across the sky when viewed through binoculars. This timing creates what some researchers are calling a configuration of a multi-body alignment, in ways that have not occurred since before modern space weather tracking systems were developed, as if the universe is providing us with a natural experiment in cosmic electrodynamics, one designed to test theories about how celestial mechanics can influence terrestrial processes. But here is what makes this period particularly interesting. From a scientific perspective, we are not just dealing with ordinary comets that follow predictable orbits. Comet BAE Atlas carries chemistry and materials from another star system, potentially reacting to solar heating in ways that no object in our local comet population has ever before. Its enormous carbon dioxide coma represents unexplored territory in plasma physics, a structure that could interact with heliospheric conditions in completely unprecedented ways. The observational situation during this period presents both opportunities and challenges for observers. On the ground, Comet B Atlas itself will be on the far side of the Sun for much of October, making direct observation impossible from the Earth's surface. But space-based telescopes continue to monitor the object's evolution, and its electromagnetic signature remains detectable through radio and X-ray observations. Through the Sun's glare, Comet Swan offers a better observational prospect for amateur astronomers, its tail already stretching about 2.5 degrees across the sky, which is about 5 times the width of the full moon. An impressive sight for anyone with access to dark skies and basic optical equipment, as it makes its closest approach. The tail may become visible to the naked eye in locations free from light pollution. More importantly, both objects will be interacting with increasingly dynamic solar wind conditions. As the Sun approaches solar maximum, recent weeks have already seen G3-level geomagnetic storms, heightened solar flare activity, and coronal hole streams creating electromagnetic conditions that some researchers link to seismic activity, a natural experiment. This convergence of factors creates what can be described as a natural stress test for theories about the influence of space weather on terrestrial processes. If the electromagnetic link between heliospheric conditions and seismic activity is real, then the October period will provide the most compelling evidence we have ever had. The global seismic monitoring community is watching this period with particular interest, not because they actually believe in space weather-induced earthquakes, but because of the sheer number of variables involved, creating an unprecedented natural experiment. Multiple celestial bodies, heightened solar activity, and a planet still adjusting to major stress changes from the earthquake in Kamchatka in July. It's a combination that could reveal something significant about how these systems interact from a more speculative perspective. Some researchers have proposed that the October alignment represents, for a kind of astronomical new beginning, a moment, when celestial mechanics resets into new configurations that can influence everything, from space weather to the electromagnetic environment around Earth. This idea is not based on established physics, but rather on pattern recognition from historical astronomical records. Looking at this symbolically, rather than scientifically, the event on October 21st occurred in the constellation Virgo by astronomical coordinates, although astrological tradition would place it in Libra due to the precession of Earth's axis over millennia. Symbolic frameworks do not affect physical processes, but they provide the cultural context that humans have used to interpret celestial events for thousands of years. Psychological impact. The psychological impact of such conjunctions should not be underestimated when many dramatic astronomical events occur. At the same time, it creates a sense of cosmic significance that can influence human behavior in measurable ways. Financial markets, social movements, and personal decisions all show statistical fluctuations that correlate with periods of high astronomical drama, the debris trail hypothesis. But let's return to harder science. The debris trail hypothesis relates to comet BAI Atlas, adding a layer of complexity to the November scenario. Preliminary calculations suggest that Earth may encounter streams of dust and particles from this object around the year 2216, creating the possibility of a meteor shower from interstellar materials. These encounters, if they happen, would provide the first opportunity for us to directly sample material from another star system in Earth-based laboratories. The chemical analysis of such particles could reveal details about star formation, interstellar chemistry, and the conditions that exist in the space between stars. However, it is important to emphasize that no official space agency has confirmed dangerous debris from comet BAI Atlas. The object's orbit keeps it far from Earth's trajectory, and its dust production seems to be following the usual rules for comets, despite its unusual scale. The unknowns, the real unknown in all of this, is how the various electromagnetic interactions will combine during the peak activity phase, solar wind conditions, and the plasma environment. The diverse comet and the dynamics of Earth's magnetosphere create a three-body problem in space physics, which cannot be solved analytically, though computer models can provide estimates. But the actual behavior will only be revealed through observation. The perihelion passage on October 30th represents the culmination of space-based observations of comet BAI Atlas, as the object orbits the Sun at its closest point. The solar heat will vaporize surface ice at a maximum rate, potentially expanding the coma to a size exceeding the diameter of the Sun itself. The opportunity for spectral analysis during this phase is unprecedented, and every major space telescope with solar observation capabilities will be focused on comet BAI Atlas, gathering data on interstellar chemistry, plasma interactions, and electric field structures that we have never been able to study before. Ground-based radio telescopes will monitor electromagnetic emissions from the interaction region, while X-ray observatories track the high-energy processes within the comet's ionized components. The data gathered during this phase will likely keep plasma physicists busy for years, trying to understand what they have observed regarding the impact on Earth. From a terrestrial perspective, the main question is whether any of these astronomical events can translate into measurable effects on our ground-based systems. The seismic correlations we have explored, the electromagnetic anomalies associated with geomagnetic storms, and the various theories about space weather triggers all face their greatest test in the October convergence. If the influence of space weather on seismic activity is real, this period will provide clear evidence. If not, the absence of a correlation during such a period of intense astronomical activity would serve to refute this hypothesis. Either way, we are about to obtain definitive answers to long-debated questions. For many decades, the danger wasn't that something catastrophic would happen. It was that we might discover our understanding of how the solar system works was far more incomplete than we realized. The universe is about to conduct an experiment in cosmic physics on a scale that we have never witnessed before, and whether we are ready to understand the results remains an open question, but ready or not. October of 2025 will reshape our knowledge of the electromagnetic environment in which we live, and our place within the broader cosmic community. The convergence is coming, and with it, answers to questions that we have only recently learned to ask. Part 11. The entire comet swarm. If you thought Comet BI Atlas was moving alone through this cosmic theater, prepare to significantly expand your perspective. The final months of 2025 are witnessing what astronomers are calling a comet swarm. 7 distinct objects converging on the inner solar system, simultaneously creating the most crowded and scientifically richest period for comet observation and observational history. Let's meet the entire cast of this celestial drama. Each object brings its own unique characteristics and scientific value, adding to the mystery of the show. The main actor, Comet BI Atlas, our main feature. A heavyweight rising star with a giant carbon dioxide atmosphere, stretching half the diameter of the Sun. Perihelion on October 30th at 1.4 astronomical units, with its closest approach at 1.8 astronomical units. This celestial visitor continues to challenge conventional cometary physics, remaining active at distances where most comets would remain dormant. C 20, 22. E5 is perhaps the most visually spectacular member of this ensemble, making its closest approach to Earth, around October 19th to 21st, at just 0.216 astronomical units. This comet has developed a tail stretching 2.5 degrees across the sky, which is 5 times the width of the Moon, with its ethereal gas and dust visible through binoculars, and potentially visible to the naked eye from dark sky locations. C 2022. L6 Lemon represents unexpectedly rapid development. Our initial brightness forecasts suggested a modest performance, but recent observations show the object brightening much faster than predicted. Current models suggest it could reach magnitude 4 by late October, bright enough to be visible to the naked eye under relatively dark skies. Lemon's rapid development made it a favored choice for amateur astronomers, tracking its development night by night. C 2025 K1 Atlas, not to be confused with our interstellar visitor, reached perihelion on October 8th. This more conventional comet offered an observational opportunity in the early autumn, before the conjunction, serving as a warm-up act for the spectacular celestial show to come. Comet 210P Christensen, appearing in early November. It represents the type of periodic comet on our list. Unlike the long-period visitors, having been observed on previous passes, Christensen follows a predictable orbit, bringing it back to the inner solar system every few years. This familiarity makes it an ideal comparison object for studying the unusual behaviors of interstellar objects and long-period objects. 24P. Shao Massa extends the performance into late 2025 and early 2026, providing continuity as the main October convergence disperses. The extended visibility of this periodic comet offers a chance to study how different objects react to varying solar wind conditions as solar cycle 25 progresses. C 2023 A3 Atlas. Finally, we should note, the early performer of 2025 provided spectacular observations of its solar grazing paths before this group of comets assembled. Although no longer active, its previous passage established baseline measurements for space-weather interactions, helping to interpret the current convergence. The mechanism of comet tail formation. The mechanism of comet tail formation provides crucial context for understanding what we are now observing. Comets actually develop two distinct types of tails through entirely different physical processes, and their interaction reveals details about both the objects themselves and the space environment they are traversing. The dust tail forms through the simple process of pressure, solar radiation as sunlight strikes the tiny particles, ejected from the comet's nucleus. Photons transfer momentum, slowly pushing the dust away from the comet. Larger particles react less to this pressure than smaller ones, creating a characteristic curved appearance as different particles follow slightly different orbits. The ion tail operates through electromagnetic forces, not radiation pressure. When high-energy photons from the sun ionize neutral atoms and molecules in the comet's coma, they create charged particles, which immediately react with the magnetic field lines in the solar wind. These ions are swept away from the comet at tremendous speeds, creating straight, blue tails that always point directly away from the sun, regardless of the comet's orbital direction. This difference becomes important when multiple comets are active at once, under different solar wind conditions. Each object samples a slightly different electromagnetic environment, creating a natural laboratory for studying plasma physics, spanning millions of cubic kilometers of space, interacting with space weather during periods of enhanced solar activity, like the geomagnetic storms we are currently experiencing. The behavior of the ion tail becomes particularly dramatic. Coronal mass ejections can actually disconnect the ion tail from its parent comet, a phenomenon spectacularly documented by spacecraft observations. In the case of Comet Encke in 2007, when a solar eruption severed its plasma tail completely, the current solar cycle, cycle 25, is reaching its peak, making such a disconnection increasingly likely as our comet approaches perihelion. Part 12. A tsunami of energy. There is an invisible storm brewing around our planet, a storm that makes the strongest storms seem like gentle breezes in comparison. As solar cycle 25 reaches its peak, our star is unleashing electromagnetic fury on a scale that occurs only once every 11 years, and sometimes much longer. What we are witnessing is not just an increase in solar activity, but a fundamental restructuring of the electromagnetic environment that surrounds and protects our world. The numbers tell a story that is both daunting and fascinating. The sunspot number has steadily increased throughout 2022. The years 2024 and 2025 are reaching levels that far exceed many scientists' predictions. The Solar Dynamics Observatory captures daily images of the star's surface writhing with magnetic complexities, vast regions where magnetic field lines twist and tangle until they snap in violent explosions. With each eruption, the sun releases energy, equivalent to billions of nuclear weapons detonating at once. The largest X-class events launch charged particles and electromagnetic radiation across the solar system at nearly the speed of light, creating conditions in Earth's magnetosphere that can last for days or weeks after the initial blast. But it is not just the violent eruptions that define a solar maximum. The entire character of the star changes during these periods of peak activity. The solar wind becomes more variable, shifting between high-speed streams from coronal holes and slower material, denser, from active regions. The heliospheric current sheet, a giant spiral of electric current, extending from the solar equator, becomes more warped and complex, creating pockets of electromagnetic turbulence throughout the inner solar system. This is the environment that the 3 Atlas comets and the comet swarm are encountering as they make their closest approach to our star. Instead of the relatively calm, predictable space weather, characteristic of a solar minimum, they are experiencing a heliosphere that is in the throes of electromagnetic fury, a historical perspective adds significance to what we are observing. Solar cycle 25 represents the first solar maximum since the development of a truly comprehensive space weather monitoring system. Previously, cycles were tracked through sunspot numbers and ground-based magnetic field measurements. But now we have satellites across the solar system, providing real-time data on conditions that were previously unobservable. The Parker Solar Probe has ventured closer to the Sun than any artificial object in history, sampling the solar wind directly at its source and revealing magnetic field structures that challenge theoretical models. The Solar Orbiter mission provides coordinated observations from different vantage points, creating a three-dimensional map of the evolution of the solar wind as it propagates through the heliosphere. This enhanced monitoring capability means we are seeing details of the solar maximum that previous generations could not observe. The complexity is astonishing, with magnetic field lines reconnecting and reconfiguring on timescales of just a few minutes. Particle acceleration processes boosting the solar wind to over 700 kilometers per second, and electromagnetic wave phenomena propagating across astronomical distances, impacting the Earth. When these conditions meet Earth's magnetosphere, the results can be spectacular and sometimes problematic. The geomagnetic storms we have experienced throughout 2025 have produced auroral displays visible far to the south, as far as the Carolinas, while also disrupting GPS navigation systems and causing minor fluctuations in power grids. The severe G5 storm in early 2025 clearly demonstrated just how vulnerable our technological infrastructure is to the effects of space weather. Airlines rerouted transpolar flights to avoid radio communication blackouts, while power companies from Canada to Texas reported elevated levels of induced currents in their transmission systems. But what makes the current situation particularly noteworthy is that we are not just dealing with typical solar maximum conditions. The convergence of multiple comets, led by an interstellar visitor with an unprecedented electromagnetic signature, is creating space weather scenarios never before seen in recorded history. The interactions are complex. Each comet in the swarm acts as a plasma probe, sampling and reacting to the solar wind in real time. Their giant comas create interaction regions, where electromagnetic fields can be amplified, focused, or altered in ways that are not yet fully understood. The combined effect is like having multiple tuning forks all resonating simultaneously in a cosmic echo chamber. The traditional view of space weather sees it as a one-way interaction, with the sun affecting everything else in the solar system through its electromagnetic radiation and particle flow. But the presence of these massive, cometary plasma structures suggests a more complex reality, where objects within the heliosphere can influence space weather through feedback mechanisms. Comet Atlas, with a coma stretching for hundreds of thousands of kilometers, representing a particularly significant disturbance in the local electromagnetic environment. Its interaction with the solar wind generates a bow shock, magnetic field draping, and particle acceleration processes that extend much farther out than the visible atmosphere. And when multiple such objects are active simultaneously within an already turbulent heliospheric environment, the cumulative effects could theoretically influence space weather patterns throughout the inner solar system. Though this is not established science, it is the frontier of research, pushing the limits of our understanding of how electromagnetic systems operate on a cosmic scale. The cultural and psychological aspects of this electromagnetic storm also deserve consideration. Throughout human history, periods of unusual celestial activity have coincided with significant social and political shifts. Correlation does not imply causation, but it reflects a deep-seated connection between cosmic rhythms and human consciousness that cultures around the world have recognized for millennia. The current convergence of the solar maximum, multiple comets, and global societal stress creates conditions that seem poised for historical significance. Whether this represents a meaningful synchronicity or mere coincidence depends largely on your perspective, on how cosmic and terrestrial systems might be interconnected. From a purely physical standpoint, solar activity does affect Earth's electromagnetic environment in measurable ways. The global electric circuit, the system of currents that flows between the ionosphere and the Earth's surface, responds to space weather variations, which can be detected by sensitive instruments worldwide. Some researchers have proposed that these electromagnetic fluctuations could affect biological systems, from bacterial behavior to human neurological function, though the mechanisms remain hypothetical. But laboratory studies have demonstrated that living organisms can respond to electromagnetic field changes on the order of a magnitude of those caused by geomagnetic storms. If such effects exist, then periods of intense solar activity, like the one currently peaking, could theoretically influence everything, from mood and cognitive function to social behavior and decision-making processes. This idea remains on the fringes of a mainstream science, but it suggests potential pathways through which cosmic events could influence affairs on Earth. The immense energy, the metaphor of an energy tsunami, becomes particularly fitting when you consider the scale of power involved. The total electromagnetic energy contained in a severe geomagnetic storm exceeds the electrical consumption of human civilization by many orders of magnitude. This energy does not simply dissipate harmlessly. It interacts with every conductive system on and around our planet. Power grids experience induced currents, which can damage transformers and cause cascading grid failures. Pipelines experience accelerated corrosion rates as telluric currents surge through the underground infrastructure. Even the human nervous system, with its network of bioelectrical signals, also exists within this invisible ocean of electromagnetic energy. As we approach the culminating phase of convergence, in late October, the intensity of these interactions will almost certainly increase. Solar activity typically remains high for several months around the solar maximum, while the comet swarm will be reaching its peak activity as the objects reach perihelion and develop their comas, achieving maximum size along with tail development. This combination creates what could be described as a perfect storm in space weather. Multiple electromagnetic sources will be operating simultaneously in an environment already charged with the energy of the solar maximum. The effects could range from enhanced auroral displays and improved scientific observations to more serious disruptions of technological systems and infrastructure. A stress test. What we are witnessing is not just an interesting astronomical phase. It is a stress test for the electromagnetic systems that govern everything, from Earth's magnetic field to the technology that underpins modern civilization. The outcome will shape our understanding of how these systems interact and our vulnerability to future space weather events. An energy tsunami is forming, driven by forces operating on a cosmic scale, far beyond human control or influence. Our role is to observe, measure, and try to understand what these cosmic energies might mean for our planet and our place within the vast electromagnetic symphony of the solar system. Whether you interpret this as an ominous warning or an unprecedented opportunity depends on your perspective, on humanity's relationship with the cosmos. But one thing is certain: we are about to experience space weather conditions that no generation has ever witnessed, and the data we collect will shape our understanding of these phenomena for decades to come. The modern chaos. The universe has always had its strange coincidences, but September 10th, 2025, pushed the boundaries of what reason could dismiss as random chance. At precisely 11:27 a.m. Mountain Daylight Time, seismographs along Utah's Wasatch Fault registered a magnitude 4 earthquake. This tremor was centered 15 kilometers southeast of the city of Solace, at a depth of just 6 kilometers, well within the normal parameters for a region where tectonic stresses build like pressure in a kettle. But this is where rational explanation meets an uncomfortable juncture. Less than 4 hours after the ground shook, that same state witnessed a seismic event in its already fractured political atmosphere, an assassination attempt on a controversial figure. During a public event, the shooter was quickly apprehended, but the event carved the fissures deeper in a society that seemed increasingly prone to extremism. 2 events, same day, same state, with no apparent connection save for the grimness of their timing and geographical coincidence. And yet, when investigating patterns of synchronicity, during periods of heightened electromagnetic activity, even the most skeptical observer begins to wonder if there are deeper currents at play beneath the surface of apparent randomness. The scientific analysis, the earthquake itself, was unremarkable. By Utah's standards, the Wasatch Fault System has produced similar tremors for millennia, driven by the ongoing extension of the Basin and Range Province. As the western plate of North America continues its complex geological dance, magnitude 4, earthquakes occur approximately once every few months in this region, posing no unusual seismic concern for local authorities or residents. But timing, as they say, is everything. September 10th fell during a period of heightened geomagnetic activity after a G3 storm had swept through Earth's magnetosphere just a few days prior. Solar wind conditions remained disturbed with high-speed streams, recurring from persistent coronal holes, creating continuous electromagnetic disturbances in the space around our planet. Meanwhile, the political incident occurred against a backdrop of rising social tensions throughout the year 2025. Polarization metrics, the scientific measures of how divided public opinion was on key issues, had reached levels unseen since the American Civil War. The failed assassination attempt was just the latest in a series of violent incidents, seemingly reflecting the deep-seated instability unfolding in contemporary society. Statistics and correlation. From a purely statistical perspective, the simultaneous occurrence of an earthquake and a significant political event within the same geographical area proves absolutely nothing about a causal relationship. This region frequently experiences seismic activity due to its tectonic location, while political violence has become alarmingly common across the United States in recent years. Finding a temporal correlation between these events becomes almost inevitable when you are actively searching for patterns in the data. But pattern recognition is precisely what makes the human brain so incredibly effective at navigating complex environments and prone to seeing connections that may not actually exist. When 2 dramatic events occur close to each other, in time and geography, during a period of unusual space weather conditions, our cognitive systems naturally search for explanations that link them together in meaningful ways. The challenge lies in distinguishing meaningful correlations from random statistical artifacts. The earthquake catalog contains thousands of events annually, while political tensions generate hundreds of significant incidents in any given year. The opportunities for apparent synchronicity become immense, even if no real connection exists between these phenomena, which seem separate. The potential underlying mechanisms are worth exploring. Some researchers specializing in the electromagnetic influence on biological and social systems suggest that periods of enhanced space weather could indeed affect both geological processes and societal ones through related mechanisms. Geomagnetic storms can affect neurological function in sensitive individuals, while similar electromagnetic disturbances could theoretically affect the subtle stress fields that govern the timing of earthquakes. Along fault systems, the proposed mechanisms remain highly speculative and controversial within the scientific community. Changes in the global electric circuit could theoretically alter neural signaling patterns in ways that affect mood, decision-making, and social behavior. Similar electromagnetic variations could also influence electrochemical processes affecting rock strength and fluid pore pressure along active fault systems. If such effects exist, They would likely be very subtle, nudging systems that are already near a critical point, rather than creating entirely new behaviors. A politically motivated individual might be slightly more inclined to act during a period of electromagnetic disturbance, while a tectonically stressed fault system might be slightly more prone to failure when space weather conditions align in specific ways. The events in Utah illustrate the profound challenge of investigating these possibilities scientifically. Both the earthquake and the political incident occurred within contexts where they were already statistically probable. The Wasatch Fault generates frequent seismic activity due to its geological makeup, while the contemporary political climate had unfortunately made violence increasingly common across many states. The technological impact, which is less controversial, is the demonstrable effect of space weather on the technological systems that increasingly mediate human social interactions. Geomagnetic storms can disrupt GPS signals, interfere with satellite communication networks, and induce power grid instabilities, affecting everything from financial markets to social media platforms. During these periods of heightened space weather activity, these technological disruptions can propagate through interconnected systems in ways that amplify existing social tensions. Trading algorithms may behave erratically when GPS signals are affected, are impaired by the effects of space weather. Emergency communication systems could malfunction precisely when they are needed most during a crisis. Social media platforms could experience outages, hindering the normal flow of information. During a period of heightened social tension, the September events occurred during such a period of heightened electromagnetic activity, and although the specific impact on technological systems was relatively minor, the cumulative effect of many small disruptions could, theoretically, contribute to increased social tension, making dramatic events more likely to occur, statistically, beyond Utah. Similar global patterns of apparent synchronicity have emerged throughout 2025 in multiple locations worldwide. Unusual seismic activity has coincided with social unrest in some regions, while periods of severe space weather have correlated with an increase in various measures of social stress and political instability. The global protest movements that erupted during a G3 storm are another compelling example. For while the underlying social grievances had long existed before the space weather event, the timing of the widespread protests across 6 continents during days of strong geomagnetic activity suggests possible connections that warrant careful scientific investigation. The key question, and this is the key question, is whether we are witnessing genuine correlations between cosmic and terrestrial events, or are we simply caught in the natural human tendency to find patterns in random data during periods of great astronomical drama, like the present. With the convergence of comets and the solar maximum, we become more sensitive to coincidences and tend to interpret them as meaningful rather than random. As we approach the October convergence period, when multiple astronomical factors align during a time of peak solar activity, we should expect more such apparent coincidences to emerge from the chaos of daily events. The primary challenge lies in maintaining a delicate balance between healthy skepticism and an openness to possibilities that may challenge our conventional understanding of how cosmic and terrestrial systems interact. Part 6. The Anomalous Interstellar Object. In the 1970s, the astronomer Carl Sagan famously said, "We live in a universe where extraordinary claims require extraordinary evidence by that standard." By 2019, Q4 Atlas presents us with quite a puzzle. This is not just an ordinary comet wandering through the solar system. It is a messenger from the depths of space, carrying the chemistry and materials forged in the stellar nurseries of distant suns. Its official name tells the story. The I in 2I 2019 Q4 stands for interstellar, and the number 3 indicates that this is the third confirmed visitor from outside our solar system. The first visitor was Oumuamua, which puzzled astronomers when it appeared in 2017, with its cigar-like shape and mysterious acceleration. The second object, Borisov, proved to be more conventional, clearly a comet, behaving as expected as it passed through in 2019. 2. By 2019, Q4 Atlas lies somewhere between the familiar and the extraordinary, and that is what makes it so fascinating. Discovery and orbital characteristics. This object was first detected by the Atlas Asteroid Impact Warning System in 2025, appearing only as a faint dot moving against the background of stars. But orbital calculations soon revealed its true nature. This was not an asteroid or an ordinary comet. Its orbit was hyperbolic, clearly indicating a speed and angle that could only come from a distant origin, beyond the Sun's gravitational influence. Unusual activity. Initial observations revealed something unusual about 2I 2019 Q4 Atlas. To begin with, most comets remain dormant until they get close, within 23 astronomical units of the Sun, the distance of the asteroid belt. This interstellar visitor, was already showing signs of activity at a distance where the Sun's heat is almost negligible. The first detailed images from the Hubble Space Telescope confirmed what ground-based observers had suspected. By 2019, Q4 Atlas was developing a tail, the characteristic cloud of gas and dust that gives comets their distinctive appearance. This tail formed under conditions where conventional comet physics suggested it should not exist. The peculiar coma structure was even more puzzling, were the morphological details that appeared from extended observation. Unlike typical comets, which develop a relatively symmetrical coma centered on the nucleus, BI 2019 Q4 Atlas exhibited what astronomers call a forward brightening, or a coma structure where the brightest regions of the envelope lead, appearing ahead of the nucleus in its orbital motion due to rotational characteristics and surface properties, vastly different from anything among local comets. A unique chemical composition, spectroscopic analysis revealed. Another surprise. While most comets in the solar system are primarily water ice with traces of carbon monoxide and carbon dioxide, BI 2019 Q4 Atlas showed signs of being unusually rich in carbon dioxide. This composition is significant for an object formed in the frigid regions between the stars, where carbon dioxide gas remains frozen, while water ice may be depleted by various processes. Enormous coma size. The scale of BI 2019 Q4 Atlas truly sets it apart. Estimates of the nucleus size, obtained from Hubble observations and thermal modeling, indicate a relatively modest object, perhaps 3 to 6 kilometers wide. That is significant, but not unprecedented in the world of comets. What is extraordinary is the size of the coma it generated. Current measurements show the gaseous envelope surrounding BI 2019 Q4 Atlas extends at least 348,000 kilometers from its center, creating a nearly spherical cloud with a diameter of about 700,000 kilometers. To put that in perspective, you could line up nearly 50 Earths side by side across the width of this coma. That makes Comet 2019 Q4 Atlas comparable in size to some of the largest structures in the solar system. The Sun itself has a diameter of about 1.4 million kilometers, which means this comet's coma spans about half the width of our star. It is a faint bubble of gas and dust, diffusely drifting through space on a scale that challenges our intuition of what a comet should look like. Physical mechanisms. The physics behind such a giant gaseous halo. from a relatively small nucleus involves several factors unique to interstellar objects. Unlike comets in the solar system that have been processed by billions of years of solar radiation and gravitational perturbations. So 2019 Y4. Atlas represents pristine material from its original stellar environment. The mixture of ices it carries may be more volatile than anything we are familiar with, leading to enhanced outgassing even at great distances from the Sun. The object's rotation also plays a significant role. Preliminary observations suggest a rotation period of a few hours, typical for small bodies in the solar system, but the distribution of surface material may be very heterogeneous. Some regions are rich in volatile ices, while other parts remain relatively inert. This patchy structure could explain the asymmetric coma structure and the unusual brightening events. Looking ahead to future developments, as C 2019 Y4 Atlas approaches perihelion on October 30th, the coma will almost certainly continue to grow. The increasing solar heat will vaporize more ice on and below the surface, potentially expanding the coma to a size even larger than its current impressive dimensions. Some models suggest that the coma could reach a diameter exceeding 1 million kilometers, larger than the Sun itself. Interaction with the space environment. What makes this phenomenon particularly fascinating from a space physics perspective is that enormous coma is not just a passive cloud of gas and dust. It is an electrically active plasma structure, interacting with the solar wind and the interplanetary magnetic field in ways we have never had the opportunity to study before. When solar wind particles collide with the atoms and molecules, neutral in the comet's coma, they can strip away electrons, creating ions that respond to electromagnetic forces. These newly created ions are swept up by the solar wind and carried away from the comet, forming the characteristic ion tail that points away from the Sun, a natural probe of the space environment for an object with a coma stretching hundreds of thousands of kilometers. This interaction region becomes truly enormous. See 2019 Y4. Atlas is essentially dragging a spherical net through the solar wind, a net that is sensitive to variations in magnetic field strength, particle density, and plasma temperature. It has become an interplanetary probe of heliospheric conditions, reacting to space weather in ways that could provide unprecedented insights into the electromagnetic environment around the Sun. The timing of the observation is ideal. Its arrival perfectly timed for scientific research. Solar cycle 25 is approaching its activity peak, with an increase in solar flares, coronal mass ejections, and high-speed wind streams. The corona is more dynamic and turbulent than it has been in over a decade, providing 2019 Q4 Atlas with a wide variety of plasma conditions to sample and react to, yielding diverse scientific observations. NASA's James Webb Space Telescope has tracked the object's spectral evolution, while ground-based observatories monitor changes in the coma's morphology and tail development. The European Space Agency's Solar Orbiter mission is positioned to provide complementary measurements of the solar wind. As 2019 Q4 Atlas encounters different regions of the heliosphere, a natural plasma experiment in action, what we are witnessing is essentially a controlled experiment in plasma physics on a scale that is impossible to replicate in any laboratory. An object from another star system is acting as a probe of our local space environment, revealing details about magnetic field structures and particle interactions that would otherwise be invisible. On a broader scale, 2019 Q4 Atlas represents more than just a scientific opportunity. It is a reminder that our solar system is not isolated from the galaxy that surrounds it. Objects drifting between stars regularly carry the chemical signatures and physical processes of distant stellar neighborhoods. We are sampling extrasolar material and physics, delivered right to our cosmic doorstep, potentially affecting space weather The question some researchers are beginning to ask is whether 2019 Q4 Atlas might carry more than just scientific interest. Its immense electromagnetic footprint and its strange interactions with solar wind conditions have fueled speculation about whether such objects could affect space weather in measurable ways. That speculation leads to some astonishingly strange possibilities about what these interstellar visitors might represent and what they might be capable of during their brief passages through our solar system. At present, 2019 Q4 Atlas continues its ancient journey, heading toward its rendezvous with the Sun, growing brighter and more active with each passing day. Whatever secrets it holds about its distant origins, it is about to share. It connects them with us in the most dramatic way possible. The universe has sent us a messenger from interstellar space. The only question is whether we are ready to understand what it is trying to tell us. Its coma is half the diameter of the Sun. Imagine a soap bubble floating in space, like a soap bubble so enormous that you could fit 25 Earths inside it and still have room to spare. That is the scale we are talking about. When we speak of the coma of C2019 Y4 Atlas, a delicate shell of gas and dust that has grown to a size that challenges our understanding of what a comet can become. Its scale is colossal. The latest measurements from infrared space telescopes have painted a picture. That seems unbelievable. The comet's coma extends at least 348 kilometers in radius from the object's nucleus, creating an active sphere about 700 kilometers wide. To put that in a cosmic context, this interstellar visitor has created a sweeping bubble wider than half the diameter of the Sun. Compared to the Sun, that comparison is not just an interesting astronomical fact. It is a window into the physics, at work on scales we rarely encounter. The Sun is a ball of plasma, held together by its own gravity, generating temperatures of millions of degrees in its core. C2019 Y4 Atlas is a small piece of ice and rock, perhaps no larger than a small mountain, creating a structure of colossal size rivaling our Sun through completely different processes. The nature of a comet's coma. The key to understanding this phenomenon lies in the nature of cometary comas. When we see a comet in the night sky, that glowing head is not the solid nucleus. It is the cloud of gas and dust particles that has been released from the surface due to solar heating as the frozen ices sublimate, directly from a solid to a gaseous state, carrying dust particles with them, creating an expanding shell around the nucleus. Compared to a typical comet, for most comets in our solar system, this process begins gradually as they travel inside Jupiter's orbit, about 5 astronomical units from the Sun. The coma usually reaches its maximum size around perihelion, its closest point to the Sun. It then slowly dissipates as the object moves back toward the outer solar system. Unusually early activity, however. Comet C2019 Q4. Atlas was breaking all the usual rules as it began to show cometary activity, while still beyond 3.8 astronomical units from the Sun, at a distance where solar heat is almost negligible. This early onset of activity suggested that the object carried much more volatile ices than the typical water ice that dominates comets in our solar system. Its peculiar chemical composition, where spectral signatures tell part of the story, unlike local comets, which are predominantly water ice with small amounts of carbon monoxide and carbon dioxide. C2019 Q4. Atlas showed a composition dominated by carbon dioxide and other exotic substances. These materials sublimate at much lower temperatures than water, which explains how this object could sustain such a massive coma while still relatively far from the Sun. Carbon dioxide ice begins to sublimate at around -78 degrees Celsius under Earth's atmospheric pressure. and in the near vacuum of space, sublimation can occur at even lower temperatures due to the faint heat from the distant sunlight. This means that C 2019 Q4 Atlas had been continuously outgassing for months as it approached perihelion, building its enormous atmosphere, the intricate structure of the coma, particle by particle. But size alone does not capture the strangeness of this structure. The coma is not a uniform sphere of gas and dust. It is a complex, dynamic environment, where multiple physical processes occur simultaneously. Solar radiation pressure pushes small dust particles away from the sun, creating the characteristic dust tail that can stretch for millions of kilometers behind the comet. Meanwhile, the solar wind, a stream of charged particles flowing from the sun at 400 kilometers per second, interacts with the neutral gas in the comet's coma through a process called photoionization. In the process of ionization, when high-energy photons from the sun strike neutral atoms and molecules, they can knock electrons loose, creating ions. These newly created ions are then swept away by the solar wind and carried away from the comet at enormous speeds, forming a blue ion tail that always points directly away from the sun, regardless of the comet's motion. A giant plasma net for an object with a coma stretching hundreds of thousands of kilometers. This ionization process creates a vast region of chemically active plasma. Imagine, by 2019, Q4 Atlas as dragging a giant net through the solar wind, a net that constantly samples the electromagnetic environment. Around the sun, variations in the solar wind speed, density, and magnetic field all affect how the comet responds. During periods of enhanced solar activity, like the geomagnetic storms we have experienced, the interaction becomes more complex and energetic. The forward brightening phenomenon, a gradual brightening observed in BY 2019 Q4 Atlas, adds another layer of complexity to this picture. Most comets develop a relatively symmetrical coma, centered on the nucleus, but this interstellar visitor shows its brightest regions in front of the nucleus, in the direction of its orbit. This asymmetry suggests that the outgassing process is concentrated in specific regions on the surface, possibly due to the object's rotation or a non-uniform composition as Atlas spins. Different surface areas face the sun, leading to episodic outgassing, creating structures within the coma. The rate of mass loss. The scale of this activity becomes truly impressive when we consider the associated rate of mass loss. Current estimates suggest that by 2019, Q4 Atlas is losing several kilograms of material every second as it approaches perihelion. That might not sound like much, but sustained over many months, it represents thousands of tons of primordial interstellar material being dispersed throughout the inner solar system, an interstellar chemical sample. This material carries the chemical signature of the stellar environment where by 2019, Q4 Atlas formed billions of years ago. Spectroscopic analysis of the comet provides a direct sample of the chemistry between the stars, offering profound insights into the conditions around other stars that we could never otherwise obtain by any other means. An unprecedented electromagnetic phenomenon. But this comet represents more than just a scientific opportunity. It is also an electromagnetic phenomenon on an unprecedented scale, the ionized component of the coma, creating a vast region of space where plasma physics operates under conditions that we have never been able to study before. The interaction between this plasma and the local magnetic field environment could theoretically influence space weather conditions throughout the inner solar system. Some researchers have begun to speculate about whether objects like 2I2019Q4 Atlas could act as natural space weather regulators. Their immense comas act as plasma reservoirs that can amplify or dampen electromagnetic disturbances. This idea is still highly speculative, but the sheer scale of the interaction zone makes it worthy of consideration. The expansion continues as we approach perihelion on October 30th. The coma will almost certainly continue to grow, as rising solar temperatures vaporize more, surface ice potentially expanding. The coma to a size exceeding the diameter of the Sun. Some models suggest the peak coma size could reach 2 million kilometers, creating a structure larger than any permanent structure in the solar system, except for the Sun itself. Limited observability. The ability to observe this enormous structure from Earth remains limited, unfortunately. Despite its impressive size, the coma is extremely tenuous, with a particle density far lower than Earth's high-altitude atmosphere, with most of the mass concentrated in the dust tail, which may become visible to skilled observers using telescopes as the object orbits the Sun. Multi-wavelength observations. But the real drama is unfolding at wavelengths invisible to the human eye. Radio telescopes are detecting emissions from the coma's ionized component, while infrared satellites track the thermal signature of the dust particles heated by sunlight. X-ray observatories monitor the high-energy processes in the interaction zone between the comet and the solar wind. A natural plasma laboratory. What we are witnessing is a lesson in plasma physics taught by this interstellar visitor. D2019Q4 Atlas has created a natural laboratory to study electromagnetic interactions on a scale that cannot be replicated on Earth, revealing details about how matter and energy operate in the space environment around the Sun. The question of an active role. The question that is beginning to arise from all these observations is whether BY 2019 Q4 Atlas could be more than just a passive block of ice and rock wandering through space, whether an object capable of generating such enormous electromagnetic signatures could it actually influence the space weather conditions that it is sampling. That possibility leads us into a realm that is both science and science fiction, where the boundaries between natural phenomena and technological possibility begin to blur in ways that challenge our assumptions about what is possible in the cosmos. Part 13. The Archetypal Shift. Death, rebirth, and radical responsibility. Something profound shifts in the collective human psyche when the heavens begin to dance with unusual activity throughout history. Intense periods of celestial drama have coincided with fundamental transformations in how societies perceive themselves and their place in the cosmos. The cosmic convergence of late 2025. The convergence we are witnessing in late 2025 carries all the archetypal hallmarks of such transformative moments: the death of old paradigms, the birth of new possibilities, and the uncomfortable space in between, where change and radical responsibility become our only compass. October 21st, 2025 marks a new moon that astronomers calculate with mathematical precision, but one that carries symbolic weight far beyond mere celestial mechanics. This lunar reset occurs precisely as multiple cosmic factors converge in what could be described as a celestial symphony of renewal. This particular timing feels orchestrated by some cosmic intelligence, though science would caution us against ascribing intention to what could simply be a stunning coincidence. The archetypal language of death and rebirth permeates human cultures precisely because it mirrors the patterns we observe. Repeated in natural cycles, the seed must decay before it can sprout. Forest fires clear away the undergrowth to make way for new growth. Individual cells must die for organisms to renew themselves, a universal principle of transformation. These patterns operate on scales from the microscopic to the galactic, revealing the universal principles that govern transformative processes in nature. Within the symbolic framework that many cultures associate with cosmic events, the constellation Virgo traditionally represents the harvest, discernment, and the meticulous preparation necessary for new beginnings. Astronomically, the actual boundaries of the constellations differ significantly from their astrological counterparts, but the archetypal symbolism points to themes of purification and renewal that seem particularly relevant to our current times. The context of convergence is what makes this period particularly significant. Not just the celestial events themselves, but the backdrop against which they occur. Humanity stands at a crossroads, where multiple crises converge: environmental challenges, technological disruption, social fragmentation, and the persistent question of whether the human species can evolve beyond its current limitations before those limitations become catastrophic. The concept of radical responsibility emerges naturally from such moments of convergence. When external circumstances become chaotic and unpredictable, the only reliable constant becomes the ability to choose how we respond to whatever arises. This is not about controlling outcomes, which remain largely beyond any single individual's power, but about taking full responsibility for one's response to the uncontrollable. Relinquishing victim consciousness, radical responsibility means abandoning the comfortable illusion that we are passive victims of external events. It demands the recognition that our perceptions, interpretations, and responses to circumstances are choices we make moment by moment, even when those choices seem automatic or predetermined. The shift from unconscious reaction to conscious response represents perhaps the most significant evolution available to each human being. Integrating the shadow. The process of shadow integration becomes particularly crucial during periods of collective stress and polarization, when society fragments into opposing factions. Each side tends to project its unacknowledged shadow onto the opposing faction, creating reciprocal cycles of vilification, making genuine communication increasingly difficult. This cosmic convergence offers an opportunity to recognize these projective dynamics and to reclaim the shadow aspects that we have disowned. Shadow work is not pleasant or comfortable. It requires acknowledging the parts of ourselves that we would rather deny: our cruelty, our ignorance, and the capacity for destruction that exists within every human being. But until we acknowledge these potentials within ourselves, we remain vulnerable to acting them out unconsciously, while righteously condemning their expression in others. Social polarization. The polarization we observe in contemporary society reflects this process of collective shadow projection. Operating on a mass scale, political opponents become demonic figures, rather than fellow human beings with different perspectives and priorities. Social media algorithms amplify these dynamics by creating echo chambers that reinforce existing beliefs while demonizing alternative viewpoints. Fierce compassion. Breaking free from these patterns requires what some traditions call fierce compassion, the willingness to extend genuine understanding even to those whose actions we find reprehensible. This does not mean condoning harmful behavior or abandoning appropriate boundaries, but rather recognizing the shared humanity that exists even in those who have lost their way. Love and forgiveness. The love and forgiveness aspect of radical responsibility is perhaps its most challenging aspect. Forgiveness, rightly understood, is not about excusing hurtful behavior or pretending that injustices have not occurred. Instead, it is about releasing the toxic burden of resentment, which ultimately harms the forgiver more than the forgiven. It is recognizing that holding on to anger and hatred only perpetuates the very cycles we claim to oppose. Self-forgiveness. This forgiveness extends not only to others, but perhaps most importantly, to ourselves. The perfectionistic tendencies that drive much of human suffering stems from not accepting limitations and one's own mistakes. Radical responsibility involves accepting one's own humanity, the capacity for error, to grow and transform without self-blame or self-delusion, accelerating the evolution of consciousness during periods of cosmic convergence like the present. The opportunity for a significant acceleration in the evolution of consciousness. An enhanced electromagnetic environment can indeed influence neurological function in subtle ways. making the expansion of awareness more accessible. The symbolic power of celestial events creates portals in the collective consciousness, facilitating breakthrough insights and transformative experiences. Active participation. But these opportunities demand active engagement, not passive waiting. Cosmic energies provide favorable conditions for growth, but individual choice and effort remain essential components of any real transformation. The universe may be extending invitations to evolve, but we must choose whether to accept those invitations and do the work they require. Daily practice. The practical integration of these principles begins with simple daily practices that cultivate awareness and responsibility. Meditation or contemplative practices help develop the ability to observe mental and emotional patterns without being completely identified with them. Journaling can illuminate unconscious assumptions and reactive patterns that often operate below the threshold of awareness. Physical practices connect us with natural rhythms. Spending time outdoors, eating seasonally, aligning sleep habits with lunar cycles, can help attune individual consciousness with larger cosmic patterns. Community connection. Community engagement provides an essential foundation for archetypal transformative processes. Personal insights, without collective expression, often remain abstract and ineffective. Seek ways to contribute meaningfully to the well-being of the community, whether through volunteer service, artistic expression, or simply by showing up authentically. In relationships helps to integrate transformative insights and the reality of letting go for rebirth. The cycle of death and rebirth requires letting go of attachments to identities and patterns that no longer serve our highest potential. This may mean relinquishing professional identities that have become restrictive, recurring relationship patterns, unconscious dynamics, or limiting belief systems that hinder our ability to grow and serve. The invitation of the convergence as October 21st approaches, followed by the peak convergence period when B 2019 Q4 Atlas reaches perihelion. The archetypal invitation becomes increasingly clear. The old ways of being human, characterized by unconscious reactivity, shadow projection, and victim consciousness are proving inadequate to meet the current challenges. Symbolic support. The cosmic convergence offers powerful symbolic support for choosing conscious evolution instead, but the ultimate transformation still is a choice that each individual must make. The cosmos may provide favorable conditions and symbolic encouragement, but the actual work of conscious evolution requires courage, commitment, and radical honesty about who we are and who we can become. The ultimate question, the question posed to us, is not whether cosmic events influence human consciousness, but whether we have the wisdom and courage to respond to whatever influences exist in ways that serve the highest good of all life on Earth. Part 14. Conclusion. The Cosmic Journey and Manifestation. We stand at the threshold of November 2025. After having witnessed one of the most dramatic astronomical periods in modern history, the undeniable truths. The truth is undeniable. Our sun has awakened from its slumber, with solar cycle 25 reaching unprecedented levels of activity. Numerous comets, including the confirmed interstellar visitor from Babai, 2019 Q4 Atlas, have painted the sky with ethereal brushstrokes of plasma and dust. The Earth has responded with seismic punctuations, from the powerful 8.8 magnitude earthquake in Kamchatka to the chains of ongoing aftershocks that remind us of the profound forces operating beneath our feet. A fundamental question. But as our investigation draws to a close, we find ourselves facing an even more fundamental one. Whether these events are causally connected, we are compelled to consider how we process information during periods of cosmic intensity, and what that reveals about human consciousness itself. The universe seems to be conducting experiments, not just in astrophysics and geophysics, but in the very nature of perception and meaning-making. The range of possibilities, the spectrum of possibilities we have explored stretches, from established scientific facts to the wildest speculative fictions. The established facts. Solar cycle 25 is proving significantly more active than forecast, producing geomagnetic storms of class G4 that have disrupted technological systems and painted auroral displays across latitudes, far from their usual polar confines. The roster of comets from C 2019 Q4, Atlas, with its immense cloud stretching half the sun's diameter, to the impressive tail of Swan, visible with binoculars, represent real, documented astronomical phenomena. By organizations from NASA to the European Space Agency, the earthquake swarms in Kamchatka, Cuba, and other seismically active regions have been precisely measured by a network of sensitive instruments. Statistical correlations, the temporal correlations with space weather events, while intriguing, remain in the realm of statistical curiosity rather than established causality. Science demands a higher standard of evidence than mere temporal coincidence, no matter how compelling the patterns may seem. A profound finding on consciousness, however, even as we maintain a proper skepticism about causality, something profound has emerged from our investigation, which transcends the specific claims we have examined. The process of tracking these correlations has revealed how human consciousness responds to periods of dramatic cosmic activity, and why such periods have historically coincided with significant cultural and societal transformations. Pattern recognition systems. During times of celestial intensity, our pattern recognition systems become overactive, searching for connections and meanings that we might normally overlook. This heightened sensitivity is not necessarily a flaw in human perception throughout our evolutionary history. Periods of environmental stress are precisely when careful attention to subtle correlations provided a survival advantage. Our brains may be naturally calibrated to detect meaningful patterns during periods of cosmic activity, because those patterns have historically been significant for our ancestors. The challenge of the information age. The challenge in our modern, saturated information environment is to distinguish signal from noise. When our pattern detection systems are operating at maximum sensitivity, the constant stream of data from global communication networks means that we are aware of more simultaneous events than any previous generation. The opportunity for apparent synchronicity increases exponentially when you monitor earthquake databases, space weather, political developments, and astronomical observations in real time. Opportunity and danger. This presents both an unprecedented opportunity and a significant danger. The opportunity lies in our ability to observe correlations across multiple domains with incredible precision and vast scope. Never before have humans possessed such detailed real-time information about conditions throughout the entire solar system, tectonic processes across the planet, and social dynamics worldwide. The danger lies in our susceptibility to information overload and pattern-matching errors. During periods of heightened sensitivity, when everything seems to connect to everything else, genuine insights become indistinguishable from elaborate coincidences. The relationship with creativity. Perhaps the most significant finding from our research concerns the relationship between cosmic events and human creativity. Historical analysis shows that periods of intense astronomical activity have consistently coincided with breakthrough innovations in art, science, philosophy, and technology. Whether this reflects a causal influence or simply the inspirational power of spectacular celestial displays, the correlation suggests cosmic convergences, like the present one, offer unique opportunities for expanded awareness and creative expression. Optimal conditions for creativity. Periods of solar maximum seem to particularly correlate with an increase in human creativity and innovation across various fields. The enhanced electromagnetic environment may indeed influence neurological function in subtle ways, creating conditions for breakthrough insights and novel connections between previously unrelated concepts. Alternatively, the symbolic power of the cosmic drama may simply offer psychological permission for thinking beyond conventional boundaries. Either way, the practical implications remain unchanged. Periods like the current convergence offer optimal conditions for creative projects, learning endeavors, and consciousness-expanding practices. The heightened electromagnetic environment, whether through direct biological effects or symbolic inspiration, seems to facilitate the kind of non-linear thinking that generates true innovation and profound insight integrated into daily life. For those who have followed our investigation from the beginning, the question now is how to integrate these insights into practical, everyday experience. The cosmic convergence of late 2025 presents a unique laboratory for experimenting with expanded awareness. But the principles we have explored will remain relevant long after Y 2019 Q4 Atlas completes. Its journey around the Sun and the comet swarm disperses throughout the outer solar system. Develop reliable sources of information. Practical integration begins by developing reliable sources for monitoring the phenomena we have discussed. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center provides real-time information, monitoring solar activity and geomagnetic conditions. The United States Geological Survey maintains a comprehensive earthquake database with immediate alert capabilities. Astronomical software and websites provide detailed tracking information for comets, planetary positions, and other celestial events. Discerning information, but information without discernment, is merely entertainment or fuel for anxiety. The key lies in developing the ability to process cosmic information in empowering ways. Instead of overwhelming consciousness, this requires cultivating what might be called a cosmic perspective, the ability to maintain awareness of the larger patterns and cycles, while remaining grounded in immediate practical responsibilities. A cosmic perspective involves recognizing that we are embedded within multiple cycles, operating on vastly different timescales. The 11-year solar cycle is just one rhythm in a symphony that includes lunar months, seasonal variations, planetary orbital periods, and galactic rotations that span hundreds of millions of years. Understanding our place, our short human lifespans offer only tiny glimpses into these grander patterns, but even a partial awareness can offer profound insights into our place in the cosmic order. The principle of practical manifestation. The principles of manifestation that emerge from this inquiry are not about thought, magic, or wishful manifestation. They are about recognizing the heightened creative potential that becomes available during periods of cosmic intensity and learning to navigate that potential constructively. Periods of high solar activity seem to amplify both positive expressions and negative ones, making the conscious direction of creative energy especially important. Attention to mental state. This means paying careful attention to one's mental and emotional states during periods of heightened space weather activity. Negative thoughts and stress responses can be unusually amplified when cosmic conditions are elevated, while positive intentions and constructive projects may in turn receive unexpected support and acceleration during such phases. Timeless lessons. As we move toward the completion of solar cycle 25 and the gradual dispersion of the comet swarm throughout the outer solar system, the lessons from this inquiry extend far beyond the specific events we have tracked. We have learned something vital about the relationship between cosmic rhythms and human consciousness, between celestial mechanics and earthly creativity, between scientific skepticism and spiritual curiosity. A testament from the cosmos, the universe has offered us a stunning demonstration of its creative power through the convergence at the end of 2025. How we integrate the insights from this display will determine not only our ability to understand future cosmic events, but also our ability to consciously participate in the ongoing evolution of planetary consciousness. Ultimately, as the heavens change, we too change. The cosmic journey continues, and our role, as conscious observers, becomes ever more important to the unfolding story of life in the cosmos.